Hello, and welcome to the Snoozy Scientist, where we explore the deepest mysteries of science, one sleepy yawn at a time. I'm really glad you're here tonight. Wherever you're tuning in from, this soft corner of the universe was made just for you. A quiet space where science and stillness can sit side by side. Tonight, we'll drift slowly toward one of the most mysterious places in our solar system, a planet that's red, cold, and silent, but never truly still. For decades, NASA has been scanning, probing, and roving across the surface of Mars, searching for signs of life. But instead of answers, they found more questions. And not everything they found made sense. Among the red dust and jagged rocks, strange things have appeared, from doorways carved into stone, as if leading somewhere beneath the surface, to a giant face half buried, staring, as if watching or waiting. These aren't stories pulled from science fiction. They are anomalies captured by NASA's own rovers, orbiters, and high resolution instruments, real images, real data, and real mysteries that still puzzle scientists to this day. So the question now is, what if Mars isn't just a frozen wasteland? What if it's a silent archive, a planet that remembers things we've only just begun to imagine? What if it's trying to tell us something? Tonight, we'll uncover the strangest discoveries NASA has ever made on Mars. Not the headlines, not the theories, but the quiet, documented anomalies that scientists are still looking for answers to. Some are eerie, some are oddly beautiful, and some are quietly terrifying in what they suggest. If you're already enjoying this peaceful moment of wonder, it would mean so much if you gave this video a gentle like or subscribed if you'd like more sleepy science stories like this. And if you don't mind, tell me in the comments, where in the world are you watching from tonight, and what time is it there? I love watching our bedtime map grow, one curious dreamer at a time. So now, take a breath, let your thoughts settle, because once you've seen what Mars is hiding, you may never see it the same way again. In May of 2022, a photograph from the surface of Mars started circling the internet. It came from NASA's Curiosity rover, which had been slowly exploring the ancient terrain of Gale Crater for nearly a decade. The rover captured thousands of photos over the years, landscapes, rock formations, dust devils, and sunsets, but this one was different. It showed the side of a sloped Martian hill, blanketed in rough, dusty terrain, and carved right into the rock was something that looked strangely out of place, a dark, rectangular void, a clean, vertical cut into the hillside. The edges appeared sharp, almost architectural, and it looked like a doorway, not a crack or an erosion pattern, but an actual opening, as if something or someone had once walked through it. Within hours of being published, the image went viral. People from all over the world zoomed in, enhanced it, adjusted the contrast, and began asking questions. Was this a passage into an underground chamber, a ventilation shaft from something buried below? Or was it just another Martian illusion, a trick of lighting, angle, and coincidence? NASA responded quickly. In their explanation, they described it as a small rock fracture, likely caused by natural geological stresses. According to their estimates, the doorway was no taller than 30 centimeters, just about 1 foot high. That would make it far too small for any intelligent life to have built or used, at least in any way familiar to us. They added that similar fractures appear on Earth, especially in sandstone and layered rock. Over time, wind, sand, and pressure can form natural breaks that happen to look symmetrical. They acknowledged the visual curiosity of the image, but reassured the public it was nothing extraordinary. Still, many weren't convinced. The image, even in its raw, unprocessed state, looked too precise for comfort. The shadows inside the doorway were dark and even, creating a visual contrast that made the opening look deep as if it continued into the hill. The top ledge appeared straight, almost horizontal, and the right edge seemed unnaturally vertical. The rest of the rock wall was jagged and chaotic, yet this small section stood out like a perfect slice in stone. Viewers began pointing out that the doorway matched architectural proportions, even if it was small. The alignment of the lines, the shape of the cut, all of it resembled entrances found in ancient ruins here on Earth. Some people suggested it could be a miniature doorway, made not for humans, but for something else. Others speculated that what we were seeing wasn't the full picture, that only part of the entrance was visible, with the rest buried or eroded away over time. A different theory emerged from those who believe Mars may still hold secrets beneath its surface. They suggested the doorway might be a ventilation tunnel, a pressure release opening, or even a collapsed entry into a larger network of hollow spaces underground. After all, Mars is known to have lava tubes, long cavernous tunnels created by ancient volcanic activity. On Earth, similar tubes often have collapsed ceilings or exposed openings. If that's possible here, why not there? Adding fuel to the idea, previous satellite data has shown heat signatures and radar anomalies beneath the Martian crust, areas that suggest hollow regions or layers of unusual density. Some believe these could point to underground water, ice, or even chambers that haven't yet been explored. So when the Curiosity rover captured what looked like a doorway, many minds went there instantly. The fact that NASA downplayed the image only made it more intriguing for some. They weren't necessarily accusing the agency of lying, but rather of not asking the bigger questions. From that perspective, even if the doorway is small, it could still be part of something larger, something deeper that hasn't been revealed. The rover only captured a limited view from a specific angle in a single moment. What else might be just out of frame? Then there's the psychological side. Our brains are wired to recognize patterns, especially faces, shapes, and structures. This tendency, called pareidolia, explains why we see animals in clouds or people in tree bark. Mars, with its barren landscapes and alien terrain, is a perfect canvas for the imagination. But at the same time, space exploration has taught us that some of our most outlandish ideas have turned out to be true. Planets with underground oceans, moons with geysers, solar flares powerful enough to reach across millions of miles. The boundary between speculation and discovery is thinner than it seems. In the case of the Mars doorway, maybe it really is just a rock fracture, a lucky coincidence shaped by wind, time, and erosion. But maybe it's more. Not a grand monument or evidence of intelligent life, but a clue, a quiet anomaly, a reminder that even on a world we call lifeless, the land itself still raises questions we don't yet have the tools to answer. And as the Curiosity rover continues to climb slowly through the ancient hills of Gale Crater, capturing images and collecting samples, it leaves behind moments like this, small, strange glimpses that make us stop and wonder. If a tiny doorway can appear in a rock face, what else might be hiding in plain sight? As the Curiosity rover continued its slow climb through the dusty hills of Gale Crater, it wasn't the first robot to have uncovered strange patterns on the Martian surface. Nearly 2 decades earlier, another rover named Opportunity had made its own journey across the plains of Mars, and in doing so found something that left scientists both fascinated and puzzled. In 2004, just a few weeks into its mission, Opportunity landed on a flat, rocky area called Meridian Planum. It was expected to study soil composition, dust patterns, and signs of ancient water, nothing out of the ordinary. But as the rover looked more closely at the terrain beneath its wheels, it began sending back images of something unexpected. Scattered across the reddish soil were tiny, smooth, perfectly round spheres, thousands of them. They were embedded in rock, littered across the ground, and clustered in small groups like berries fallen from a tree. Some were poking out from weathered stone, while others sat loose, untouched by time. In some places, they were so densely packed that they looked like seeds pressed into the planet itself. Scientists quickly took notice. These formations weren't dust particles or sand grains. They were small, about the size of BB pellets, but distinct in shape and texture. Each one looked like a miniature marble, solid and almost symmetrical. Because of their appearance, researchers at NASA informally began calling them blueberries. Of course, they weren't blue. The Martian dust tinted everything in shades of rust and brown, but the name stuck and the mystery deepened. What were these blueberries made of? And more importantly, how did they get there? The instrument's onboard opportunity helped answer at least part of the question. The blueberries were rich in a mineral called hematite, a form of iron oxide that can form in water on Earth. On our planet, hematite concretions can develop when mineral rich water flows through porous rock, slowly building up layers of iron over time. The result, in some cases, is the creation of spherical stones. This led NASA to a strong theory that these Martian blueberries were formed in the presence of liquid water, not just once, but over long periods of time. The implications were huge. It meant that Meridian Planum wasn't always a dry, dusty plain. At some point in Mars's past, water had likely flowed through its rocks, changing their chemistry and leaving behind these tiny iron-rich remnants. For the scientists studying them, the blueberries were more than just a curiosity. They were a mineral fossil of Mars's watery history. But the questions didn't stop there, because even if water played a role, the level of uniformity was still surprising. On Earth, natural processes often produce variety. No two snowflakes are identical. Stones weather in different ways, but here, the blueberries seemed consistent, round, smooth, evenly sized. That level of similarity felt deliberate. Some researchers noted that Martian gravity, erosion rates, and atmospheric pressure are all different from Earth's and could lead to unfamiliar patterns in how rocks form or weather. Others wondered if wind played a role. Perhaps over millions of years, Martian dust storms polished these spheres until they were smooth as glass. But even with these possibilities, the exact steps of their formation remain uncertain. Another point of interest was how they were distributed. In some areas, the blueberries were deeply embedded in bedrock, almost as if they had grown inside it. In other places, they were scattered loosely on the surface, sitting freely as if released from their stony container. This variation suggested that different geological processes may have been at play, either forming them underground or exposing them through erosion. In 2012, NASA's Curiosity rover also spotted similar spherical formations in a completely different part of Mars, further confirming that the blueberries weren't isolated to one region. Whatever forces had created them, they had worked across wide swaths of the planet, leaving behind repeating patterns that felt strangely intentional. Some geologists have drawn comparisons between Martian blueberries and certain formations found in Utah and other arid regions of Earth, where mineral-rich water once flowed through sandstone, forming iron concretions. But while those earthly versions are often irregular or ovoid in shape, the Martian examples maintain their near-perfect roundness far more consistently. And so the blueberries remain one of Mars's quiet mysteries, a natural phenomenon likely formed in water, yet still odd enough to feel out of place. Their sheer number, their uniform shape, and their presence across distant locations all point to something we don't fully understand. Like the doorway before them, they challenge what we expect to find on a supposedly lifeless planet. And as the rovers continue their slow, methodical work, inching forward one photo and one sample at a time, these small, scattered spheres sit patiently beneath the dust, silent clues from a time when Mars may have looked very different. Not all of Mars' mysteries can be seen in photographs. Some of the most puzzling clues about the planet's hidden nature come not from rocks or shadows, but from the air itself. Because while the rovers quietly explore the dusty surface and capture strange formations with their cameras, their sensors also pay close attention to the invisible, the gases that drift through the thin Martian atmosphere. In 2013, the Curiosity rover, stationed inside the ancient Gale crater, detected something completely unexpected: a sudden rise in methane. A simple gas made of carbon and hydrogen appeared in the readings from its onboard sensors. The spike was small but clear. The air above the surface showed a temporary increase in methane concentration, and then, just as strangely, it vanished again. No obvious pattern, no visible source, just a sharp appearance, and then nothing. This discovery wasn't supposed to happen. Mars has an extremely thin atmosphere, and the presence of methane, especially in sudden bursts, had not been predicted. On Earth, methane is mostly produced by living organisms. It comes from wetlands, cows, landfills, and bacteria deep underground. But it can also come from non-living sources, like certain types of volcanic activity or the interaction of water with specific rocks. When scientists saw those first Martian methane spikes, the immediate question was, where is it coming from? Methane isn't stable in sunlight. It breaks down quickly when exposed to radiation from the sun, especially on a planet like Mars, which has no protective magnetic field or thick atmosphere. This means that if methane is present, something must be producing it, right now in the present. It can't just be left over from millions of years ago. It has to be active. The next step was to confirm the finding. Other instruments, located not on the surface but orbiting Mars from above, also began scanning for traces of methane. The European Space Agency's Mars Express orbiter detected possible signs. Later, the ExoMars Trace Gas Orbiter was launched with the specific goal of tracking down this mystery. But oddly, its results didn't always match what Curiosity was seeing. Sometimes methane showed up at the surface, but not in the upper atmosphere. Other times, orbiters caught glimpses of methane plumes, but nothing consistent enough to predict. This added to the confusion. If methane was real, and multiple instruments had seen it, why did it appear and disappear so quickly? And why didn't every spacecraft see it at the same time? Some scientists believe that local bursts of methane may be seeping out from beneath the ground. Cracks in the surface or shifting soil could briefly release tiny amounts, which then vanish quickly into the atmosphere before they rise high enough to be detected from orbit. Others suggest that certain minerals beneath the surface might be releasing methane through a chemical reaction, perhaps triggered by changes in temperature, pressure, or even seismic activity. But the more intriguing possibility is that something biological is at work. On Earth, there are microbes called methanogens, tiny life forms that live in places with no oxygen, like deep underground, inside ice, or in extreme environments. These microbes give off methane as a byproduct of their metabolism. If anything like them exists beneath the Martian surface, even at the microbial level, it could explain the methane spikes. Not as a constant presence, but as something that comes and goes depending on conditions. Warmth, movement, or seasonal changes could all play a role. Curiosity's data showed that some methane events occurred during warmer months, and occasionally during night hours when temperature shifts might trigger subsurface activity. The timing wasn't regular enough to form a pattern, but it hinted at cycles, gentle, quiet pulses of something happening below. If methane is truly coming from living organisms, it would be the first indirect sign of life beyond Earth. Not intelligent life, not visible life, but life all the same. The kind that survives in the dark, hidden under layers of frozen dust and rock. The kind that leaves no bones or ruins, but leaves a chemical fingerprint in the air. Scientists have been cautious in drawing conclusions. Every spike, every disappearance, every detection and non detection has led to more questions than answers. Some call it geological noise, the result of non living chemical reactions that mimic biology. Others argue the inconsistencies are due to equipment sensitivity, atmospheric conditions, or limited data. But the fact remains methane is appearing on Mars. Not constantly, not predictably, but undeniably, and its presence suggests that something, somewhere on or beneath the surface, is active. Whether that activity is chemical, geological, or biological is still unknown. But it points to a planet that's not just sitting still, frozen in silence. It's breathing lightly, briefly, and in ways we still don't fully understand. And as curiosity continues its slow crawl through the ancient crater floor, each reading it takes, each molecule it sniffs, could be part of something larger, a pattern waiting to be revealed, a quiet signal reaching up from beneath the dust. While the Curiosity rover scanned the air above Mars for fleeting traces of methane, a different kind of investigation was taking place far above the planet, from orbit. Using instruments that could see through the surface, scientists began peering into the planet's hidden layers, looking for clues buried deep beneath the red dust. What they found suggested that Mars may not be as dry as it seems. In 2018, a European spacecraft called the Mars Express Orbiter made a surprising discovery using a tool known as a radar sounder. This instrument sends radio waves down into the ground and listens to the signals that bounce back. The strength and timing of those echoes can reveal what lies below: solid rock, ice, or in some cases liquid. Over several passes above Mars's southern polar region, the orbiter picked up something unusual. Beneath a thick sheet of frozen carbon dioxide and water ice, about 1.5 kilometers underground, the radar detected a patch of material that reflected signals in a way scientists had not seen before on Mars. The reflections were bright and consistent, similar to how radar behaves when it hits liquid water on Earth beneath glaciers. And this strange spot wasn't tiny. It stretched for about 20 kilometers, sitting hidden beneath layers of frozen ground. The signals were puzzling. Mars is cold, far colder than Earth, and at those depths, the temperature is well below freezing. On Earth, subglacial lakes exist beneath Antarctica and Greenland, kept liquid by pressure and geothermal heat from below. But could Mars, without plate tectonics or significant internal heat, support something similar? One explanation was that the water detected wasn't just water, it was heavily laced with salt. Certain types of salt can drastically lower the freezing point of water, keeping it liquid even in extremely cold conditions. If Mars's underground lake contained a high concentration of perchlorates or other salts, it could remain in a slushy, briny state despite the harsh environment. A salty, isolated pocket of water isn't just interesting because it's rare, it's interesting because of what it might host. On Earth, even the most extreme places, deep under Antarctic ice, inside volcanic vents, or in salt saturated lakes, still support life. Tiny organisms adapted to crushing pressure, bitter cold, and total darkness continue to survive and even thrive in places we once thought were barren. If such life can exist here, why not there? The possibility of a Martian brine lake immediately raised the question: could it support microbial life? Not advanced creatures or anything large enough to see, but single celled organisms similar to those that survive in Earth's deep subsurface ecosystems. The conditions are extreme, yes, but not impossible. Microbes that feed on minerals, release gases, or slowly metabolize in frozen environments have been found in ice cores drilled from Earth's poles. These aren't fast moving forms of life. They exist on the edge of survival, suspended in cold, silence, and time. The radar data didn't prove life or even liquid water for certain, but it did provide one of the strongest pieces of evidence yet that something unusual was hiding beneath the Martian surface. The radar reflections weren't easy to explain away. Follow up passes confirmed the signature, and in later years, scientists found more reflective patches in nearby regions. These additional spots suggested a network of possible subsurface reservoirs, not just one, but several, stretching beneath the south polar layers. If these patches are truly liquid, they could represent some of the oldest and most protected environments on the planet. Shielded from radiation by thick layers of ice and dust, and undisturbed for millions of years, such environments would be prime locations to search for preserved biosignatures. Even if they no longer support life, they might contain chemical traces of something that once did. To reach these underground pockets, future missions would need to drill deep below the surface, far deeper than any rover has ever gone. It's a technological challenge, but not an impossible one. Drills capable of penetrating ice and collecting core samples already exist here on Earth. Adapting them for Mars is a matter of time, planning, and engineering. What's more, the discovery has forced scientists to reconsider what lies beneath other parts of the planet. If water can hide below the South Pole, could similar pockets exist beneath the equator or near ancient riverbeds? Could some of the mysterious methane spikes be connected to underground water? And are there layers miles beneath the surface where conditions have remained stable for eons, completely untouched by the harsh surface above? As more orbiters scan and as future missions arrive with better tools, the idea of a dry, dead Mars begins to blur. The planet may not look alive on the surface, but the deeper we look, the more it seems to shift. It creaks with ancient water, it holds heat in strange places, and in certain corners it may still be flowing, silently, slowly, deep in the dark. Beneath the Martian South Pole, radar had hinted at something hidden and possibly fluid, but even closer to the surface, in places exposed to light, heat, and time, another quiet pattern was emerging, one that moved, shifted, and returned over and over again. These were not deep secrets buried under layers of ice, but visible marks that came and went like whispers across the land. Scientists called them recurring slope lineae, or RSLs for short. They were first noticed in high resolution images captured by NASA's Mars Reconnaissance Orbiter. While scanning steep slopes, crater rims, canyon walls, and dusty cliffs, the spacecraft detected thin, dark streaks that seemed to appear in the warmer months and fade away during the colder ones. They weren't wide or deep. In fact, they looked almost like smudges or brushstrokes painted onto the hillsides, but they were consistent. They returned year after year in the same places, following the same lines. The streaks always pointed downhill, and they often stretched for hundreds of meters, winding along the curves of the land. Some appeared in clusters, branching out like tree roots or river veins. Others ran in straight, narrow bands, as if something had flowed along a tight channel and then vanished. They darkened during the Martian summer and faded when the temperature dropped, only to reappear again the next cycle in nearly the same spots. At first glance, it was tempting to see them as evidence of running water. On Earth, such seasonal streaks might come from melting snow or groundwater seeping through cracks, and with earlier discoveries of ice, ancient riverbeds, and possible underground lakes, the idea of water moving across modern Mars didn't seem impossible. But these flows, if that's what they were, didn't behave like typical water. They left no puddles, no wet surfaces, only the shifting color of dust and soil. To explain this, scientists began exploring different theories. One possibility was briny water, salty enough to remain liquid even in the cold, and thin enough to seep just beneath the surface before evaporating. If these salts were pulling moisture from the thin Martian air, even in small amounts, they might cause a shallow temporary trickle, just enough to darken the ground and leave behind a mark. But even that explanation came with problems. For one, the atmosphere is so dry that pulling usable water from it would be extremely difficult. For another, no direct traces of liquid have been found at the RSL sites. A competing theory suggested that dry sand and dust might be shifting due to seasonal temperature changes. During warmer months, carbon dioxide or water vapor trapped in the soil could be releasing just enough gas to make the surface unstable, causing fine material to slide down the slopes. These tiny avalanches could reveal darker material underneath, which would explain the color change. But that idea, too, has gaps. The streaks are narrow and sharply defined, more like lines drawn with a steady hand than the chaotic scatter of a landslide. What makes RSLs especially puzzling is how selective they are. They don't form everywhere. Only certain slopes at specific angles in particular regions show this behavior, and they follow a pattern: darken, lengthen, fade, that repeats with uncanny precision. It suggests that something is triggering them regularly, not randomly, and that something, whatever it is, still hasn't been fully pinned down. Some researchers believe that the answer might involve multiple processes happening together. Perhaps there is a trace amount of water involved, too little to collect, but enough to cause local instability. Perhaps the soil contains salts that interact with vapor just enough to weaken the upper layers of dust. Or maybe the Martian surface responds to sunlight and shadow in a way that creates cycles we don't yet understand. Whatever the cause, the consistent behavior of these streaks points to one undeniable truth: something on Mars is still active. It's not just a frozen relic of the past. The planet breathes, shifts, and changes, quietly, subtly, and seasonally. RSLs are one of the clearest signs of this movement. They remind us that Mars is not entirely still. It has rhythms, however faint, that play out across its dusty skin. These slope features are being watched closely by orbiters, photographed again and again with high-resolution cameras to track their growth and retreat. But until a lander or rover reaches one of these steep, remote locations, much of their story will remain untold. No one has touched them. No one has studied them up close. They remain just out of reach, visible, repeating, but always just beyond the edge of certainty. And as we continue scanning for patterns in the Martian dust, each line etched into those distant cliffs becomes a kind of signal, a seasonal trace of change on a world that many once thought was long dead. While seasonal streaks quietly etch themselves across Martian cliffs, responding to warmth and time, another layer of mystery lies buried even deeper, not in the soil, not in the ice, but in the invisible field around the planet itself. It's a mystery that can't be seen with the naked eye, but reveals itself in patterns, signals, and strange silences. Unlike Earth, Mars does not have a global magnetic field. Our planet is wrapped in a protective bubble generated by the spinning of molten metal deep inside its core. This magnetic field shields us from harmful solar radiation and helps hold our atmosphere in place. It also creates the beautiful auroras near our poles. But on Mars, that shield is gone. Instead of a strong, unified field, Mars has only scattered patches of magnetism locked into certain areas of its crust, like fossilized echoes from the past. These magnetic pockets aren't spread evenly. Some regions of the planet show strong magnetic signatures, while others are nearly blank. The contrast is sharp and unexplained. The first clues came from orbit. In 1999, NASA's Mars Global Surveyor carried an instrument that could measure magnetic fields. As it circled the planet, it detected alternating bands of magnetism buried within the southern highlands. These stripes ran parallel for hundreds of kilometers, flipping between positive and negative, like ancient memory tapes written into the rock. They were strong, organized, and deeply puzzling. On Earth, similar magnetic stripes are found at the bottom of our oceans. There, they're created by molten rock rising from beneath the crust, solidifying and capturing Earth's magnetic field in the process. As the magnetic poles flip over time, the new rock records each change like pages in a diary. These bands on Earth are a sign of tectonic activity, of plates moving, spreading, and rebuilding the surface. But Mars doesn't have plate tectonics, at least not in any form we understand today. The surface doesn't slide or shift the way Earth's crust does. So, how did these magnetic stripes form? What froze them into place, and why only in certain regions? The patterns hint at something that Mars may have once had, a global magnetic field, long ago. For such a field to exist, Mars would have needed a hot, spinning metallic core, just like Earth. That core would have to generate electricity through motion, producing a magnetic shield that wrapped around the entire planet. But at some point, that engine seems to have stopped. The field disappeared, and what remained was fossilized magnetism, frozen in place, like the last note of a song no longer playing. What caused that field to vanish is still unknown. One idea is that the Martian core cooled too quickly. Without enough heat to keep the metal moving, the magnetic generator may have shut down. Another theory suggests a massive impact, perhaps from an asteroid, that disrupted the internal balance and permanently silenced the dynamo inside. Without the field, solar winds swept in and began stripping away the atmosphere, leaving the dry, exposed surface we see today. But even with those broad ideas, details are missing. The magnetism isn't evenly distributed. Some ancient regions have strong signals. Others, which should also hold traces, appear magnetically blank. It's as if certain parts of the planet were protected longer or froze at different times. This patchy record makes it difficult to piece together a clear timeline of events. More recently, NASA's InSight lander brought new tools to the surface. It carried a magnetometer, a sensitive instrument to measure local magnetic fields right at ground level. What it found surprised scientists again. The magnetic signals near InSight's landing site were far stronger than expected, 10 times stronger, in fact. They didn't match what had been measured from orbit. This suggested that some of Mars's magnetism was concentrated in thin, shallow layers of rock, layers that couldn't be seen from high above. In some places, this crustal magnetism may still interact with solar radiation, creating mini auroras or deflecting particles, but they offer no real protection, and they flicker in isolated regions with no larger structure to guide them. These strange patches and layers raise new questions. If Mars once had a magnetic field, how long did it last? Did it protect early oceans or life? And if it disappeared suddenly, what was happening on the surface while the shield collapsed above it? Some researchers have even speculated about whether the core might still retain some heat or movement deep inside, enough to someday be reawakened, or at least hint at underground processes we can't yet detect. Others wonder if these localized signals could be clues pointing to geological histories we haven't yet uncovered, stories of ancient volcanoes, deep impacts, or even hidden reservoirs of minerals waiting beneath the crust. As we continue to measure, map, and explore, Mars's magnetic puzzles remain among its most haunting, not because they're unsolved, but because they speak to something that once was, a planet that spun with energy, with movement, and with force, now silent but not empty. Its magnetic past still lingers, written into the rocks in patterns we are only beginning to understand. While magnetic fields whisper about a Mars that once pulsed with energy, the planet's surface keeps offering quieter, stranger hints, this time not hidden in ancient rock layers, but lying right out in the open. Across various missions, especially through the eyes of NASA's rovers, strange looking objects have been spotted scattered on the ground. They're small, often half buried in dust, but they don't quite match the rest of the Martian terrain. In some photos, taken by Curiosity and earlier rovers like Opportunity, something appears that doesn't look natural at all. One image shows a tiny piece sticking up from the soil, short, metallic looking, and shaped like a bolt. It has a narrow body and what looks like a flat circular head. In another, there's a curved object that resembles a bent pipe with shadows that make it look hollow. In a third, something appears long, thin, and coiled, almost like a wire. These are not things that Mars should make on its own, or at least not things it makes often. The rover cameras, designed to study rocks, soil, and dust patterns, occasionally catch glimpses of these oddities while scanning the terrain. They're not the main focus. They're usually found in the background or along the edge of a larger photo. Some are barely visible unless you zoom in, but once spotted, they stand out. A line too straight, a surface too smooth, a shape that seems too familiar. Viewers on Earth have noticed. These images often spread quickly across forums, blogs, and news stories. People highlight them with circles and arrows, comparing them to Earth made tools and parts. The comparisons aren't random. Bolts, pipes, and wires are some of the most common and recognizable components of machines. So when something on Mars even slightly resembles one, it grabs attention. NASA usually labels these features as natural, rocks shaped by wind, time, and erosion, and that explanation may be true. Mars is a planet where sandstorms whip across the land at high speed, slowly sculpting everything in their path. With enough time, sharp rocks can become rounded, jagged edges can be softened. Even straight lines can form when softer material erodes away, leaving behind something harder. It's also possible that lighting and shadow play tricks on the eye, turning ordinary fragments into curious shapes. Still, some of these objects seem too precise to dismiss easily. A bolt-shaped structure doesn't just have a straight body, it appears to have a flat top and a slight ridge near the edge like threading. The pipe-shaped object doesn't blend into the surrounding rock. It arches out of the ground, catching the light in a way that makes it look separate. The wire-like feature looks coiled, not random, and it raises a question: how many times can coincidence look this familiar? One theory suggests that some of these pieces might be human-made debris. After all, Mars has hosted a number of missions, landers, rovers, parachutes, and descent stages, and some of their parts may have come loose or broken off. If these bits drifted or fell in unusual ways, they could be what's showing up in the images. But in many cases, the objects are found far from known landing zones, and often the rovers themselves don't drive close enough to examine them directly. They simply pass by. Another idea is that these shapes are just odd rock formations, weathered into unusual forms. But there's also a small, persistent group of researchers who ask a different kind of question. What if some of these pieces point to something Mars once had? Not advanced technology, not machines, but structure, design. What if, long ago, something existed here that left behind fragments too worn to identify clearly, but still strange enough to notice? NASA doesn't often issue detailed follow-ups on these discoveries. The rover teams have limited time and resources, and their goals are focused on larger scientific objectives: chemistry, geology, atmosphere. If a photo captures something strange, but it isn't scheduled for study, it usually remains just that, a strange photo. It stays in the archive, sometimes unnoticed, until someone on Earth zooms in and wonders what they're really seeing. That silence leaves room for speculation. It also highlights how much we still don't know. Mars is a world filled with debris. natural debris shaped by wind, ancient lava flows, ice movement, and meteor impacts. But here and there, mixed into the dust, are shapes that tug at something more instinctive: a straight edge, a perfect circle, a ridge that catches the light just right. And so the rover continues its slow path forward, wheels turning gently across old ground. It rolls past dust dunes, rock layers, and strange shadows. Its cameras click quietly, capturing thousands of moments, and among them, once in a while, something strange appears. A small shape that doesn't belong, a sliver of something we can't name. And like the methane, like the hidden water, like the fading streaks on distant hillsides, it joins the long list of Martian details that suggest we still don't fully understand what we're looking at. While some of the rover's discoveries sit half buried in the dust, strange bolts, pipe like shapes, and curved fragments that echo something almost mechanical, others seem to defy gravity altogether. They don't just lie on the surface, they float. Or at least that's how it looks. One of the most famous and puzzling images captured by NASA's Curiosity rover shows a small object that appears to be levitating above the Martian ground. It's a thin, slightly curved piece of material, smooth and narrow, with a long handle like shape and a rounded head. It looks unmistakably like a spoon, hovering in midair, casting a soft shadow onto the rock beneath it. The photo quickly made its way around the world. Viewers zoomed in, enhanced the contrast, flipped the angle. From almost every perspective, the illusion remained: a spoon floating a few inches off the surface, like something left behind in zero gravity. NASA didn't comment much about it, but scientists and geologists were quick to offer a grounded explanation. They said the spoon shaped object was most likely a thin rock fragment that had been carved by millions of years of wind erosion. The way it extended from the main rock wall, curving outward and narrowing at the base, was something that could happen naturally, given time and just the right conditions. They pointed to similar formations on Earth: narrow stone bridges in deserts, hanging shelves formed by layers of softer rock slowly worn away beneath harder layers. These processes, they explained, could sculpt delicate shapes that resemble tools, utensils, or even sculptures. And the reason the spoon appeared to float was because of a trick of lighting and shadows. The camera's perspective, along with the direction of the sun, had created just the right angle to make the basin visible, blending it into the background. But even with that explanation, the image continued to capture attention. Something about its shape was too familiar. The clean curve of the handle, the shallow bowl-like end, the way it cast a crisp shadow beneath it, all of it made the object feel artificial, almost as if it had been placed there. And because the Martian surface is so barren and unchanging, even the smallest unusual detail stands out. A rock shaped like a spoon is one thing, but a rock that looks like it's floating? That's something else entirely. Theories, as always, began to surface. Some suggested that the object was part of a broken tool, perhaps from the rover itself, though NASA confirmed there were no missing parts. Others went further, questioning whether it could be a remnant of something ancient, something designed, now worn smooth and light by time. But perhaps the most unusual theory to arise was the idea of magnetic levitation, that the spoon like rock was suspended by invisible forces, possibly from a magnetic field interacting with the crust below. While intriguing, this idea had little support. Mars doesn't have a global magnetic field like Earth, and the local crustal magnetism detected so far hasn't shown the strength needed to lift objects. Still, the theory stayed afloat in online discussions, partly because it captured the spirit of the mystery. On a planet where so many things appear to behave just a little differently, what seems impossible sometimes earns a second look. More than anything, The image is another example of how Mars plays tricks on the eye. The combination of unfamiliar terrain, strange lighting, and oddly shaped rocks often creates illusions, ones that echo objects we know well here on Earth. But it also raises a quieter question. Why do so many of these illusions resemble human-made things? In this case, the spoon likely isn't floating. It's a rock stretched out and thinned by years of erosion, its base hidden in the shadows. But even knowing that, the image continues to fascinate. It stirs something deeper. The way we look at shapes, the way we connect patterns, and the way we instinctively search for meaning in the unfamiliar. And it's not the only time curiosity has captured something that feels out of place. Throughout its journey across Gale Crater, the rover has sent back countless images, many of them showing odd shapes that at first glance resemble familiar tools or remnants. One looks like a statue's head worn smooth. Another resembles a door frame, just tall enough to invite speculation, and scattered among them are smaller shapes, fragments, shadows, lines that keep the eye searching. Each photo, each strange shape, adds to the quiet sense that Mars is not a blank canvas. It's filled with details, some natural, some uncanny, all silent. The spoon-like rock may not float, but the feeling it creates, that weightless pause between what we see and what we believe, is very real. As the rover continues its path across the rocky plains, its cameras still clicking through dust and silence, it passes more stones, more shapes, more mysteries. Some are easy to explain, others are not. And every now and then it captures something that seems to rise, not just from the ground, but from the edge of imagination itself. While the strange spoon-shaped rock stirred questions about what Mars might be hiding in plain sight, other discoveries were even more fleeting, so brief that they were almost missed. They weren't solid like the round blueberries, or traceable like seasonal slope streaks. They appeared in an instant, vanished just as quickly, and left behind only a flash of light on a digital screen. But even that was enough to deepen the mystery. In April 2014, Curiosity's navigation camera, or NavCam, captured something strange. While surveying the terrain near a cluster of craters, the camera snapped an image that contained a sharp, bright flash of light on the horizon. A second camera, facing a slightly different direction, recorded no such flare in the same moment. Just one clean frame, one clear burst of brightness, standing out like a match struck in the dark. A few days later, it happened again. Another flash, another silent moment frozen on the Martian surface. NASA scientists initially explained the anomaly as the result of cosmic rays, high-energy particles from space that sometimes strike the camera's detector and create false bright spots. These kinds of hits are common in space, where Earth's protective magnetic field and atmosphere can't shield instruments. Cosmic rays can create streaks, dots, and occasionally more dramatic flares, depending on how they interact with the imaging sensor. But in this case, something didn't quite line up. Cosmic ray hits tend to be random, scattered across the sensor with no clear source or direction, but the flashes Curiosity recorded had consistent positioning. They appeared near the same region of the horizon, around the same time of day, and in the same general direction. That level of repetition is unusual for purely random interference. Some suggested that the bright spots might be reflections, sunlight bouncing off shiny surfaces, or bright minerals exposed in the crater walls. That's certainly possible. Mars has many reflective materials, and certain angles between the rover, the sun, and a nearby rock face could produce short-lived glints of light. But again, the direction and timing raised questions. The rover was not moving much between these shots, yet the flashes kept showing up in that same general spot. It was as if something stationary, reflective, or possibly active was catching the light, just briefly, and sending it back to the camera. Curiosity's twin nav cams made it possible to cross-check events like this. Both cameras operate together, taking images from slightly offset positions. If a cosmic ray hits only one camera, the effect is isolated, but a real external flash, something in the environment, would likely appear in both or be captured by other sensors too. In the most famous light flash image, only one nav cam caught the flare. The other, at the same moment, showed nothing. This deepened the mystery, because while the absence in one image might support the cosmic ray theory, the apparent consistency in direction suggested it wasn't entirely random. The flashes weren't showing up across the sky, just near a specific ridge, around the same time each Martian sol. Some enthusiasts speculated more boldly. What if the lights were signals? What if some hidden mechanism beneath the surface was triggering them? A camera flash, a lensing effect, or even a heat signature rising into the cold, thin air. These ideas don't have scientific backing, but they reflect a growing curiosity. Why would the same part of Mars keep glowing if there was nothing there to glow? Another suggestion was static electricity. Mars has dust storms, and in the right conditions, charged particles could discharge light, similar to tiny lightning. But these flashes weren't associated with storm activity or darkened skies. They happened in clear daylight, with no clouds or movement visible around them. The lack of follow-up didn't help the speculation. NASA released the images, but no full report or explanation followed. The events weren't marked as priorities, perhaps because they didn't threaten the mission or reveal immediate geological insights, but they lingered in public forums where curious eyes kept returning to the same frames, zooming in, searching for patterns. If the flashes were cosmic rays, then Mars is simply reminding us of how much background noise surrounds everything in space. If they were reflections, then it means the planet is more textured and gleaming than we expect, capable of catching sunlight in fleeting moments that mimic something artificial. And if they were neither, then we're left with something even more interesting, a behavior we don't fully understand, because the lights weren't the only strange thing to come from the craters. Just beyond that horizon, as curiosity rolled forward, it would pass structures that didn't flash or glow, but seemed almost sculpted, like walls, like ridges with clean breaks. And deeper still, instruments would soon begin detecting something else, not light this time, but magnetism that didn't behave the way scientists predicted. While those fleeting flashes of light above the Martian surface puzzled scientists and viewers alike, what lay hidden just beneath the planet's crust offered something even more surprising, not in the form of light or motion, but in the quiet endurance of something long thought to be impossible on such a dry, barren world. In 2018, scientists working with NASA's Mars Reconnaissance Orbiter, particularly its powerful high-rise camera, spotted something remarkable peeking out from the dusty red soil. Along several steep cliff faces, located in mid-latitude regions of Mars, they noticed long vertical walls of exposed ice, not frost, not seasonal deposits, but solid layered water ice, visible right beneath the planet's thin covering of rock and dust. These ice cliffs weren't shallow patches or isolated crystals. They ran vertically for several meters and extended deep underground, in some locations over 100 meters down, like walls of frozen memory built into the Martian terrain. The cliffs appeared where wind or erosion had sheared away the topsoil, revealing the gleaming pale blue material beneath. It was like finding a frozen ocean locked in a canyon wall. The discovery shocked many. For years, scientists had speculated about subsurface water on Mars. Radar from orbiters hinted at possible pockets deep under the poles, and some rovers had found chemical traces suggesting past moisture. But this was different. These ice cliffs weren't hidden deep below or shielded by hundreds of meters of rock. They were near the surface, just a meter or two down in some places, and stable enough to remain intact despite the thin, dry Martian air. The high rise images revealed more than just the presence of water. They showed patterns, bands, and layers running horizontally across the ice, like growth rings inside a tree. These layers suggested cycles: freezing, snowfall, wind-blown accumulation. The cliffs seemed to preserve a climate history, capturing past Martian weather the way glaciers do on Earth. Each stratum told part of a longer story, of shifts in orbit, of ancient seasons, of atmospheric changes that shaped the red planet over millions of years. But even more compelling was what this meant for the future. Water on Mars has always been a holy grail for scientists and mission planners alike. Liquid water is necessary for life as we know it, and even frozen water, if accessible, could be crucial for future human exploration. These cliffs offered more than just proof of water. They offered potential resources, places where astronauts could someday harvest clean ice for drinking, for fuel production, even for radiation shielding, all without having to drill miles into the crust. The fact that the cliffs were found at mid-latitudes, far from the frigid polar regions, also raised new questions. How did the ice get there? Why did it stay frozen in areas where surface temperatures can vary so dramatically? The working theory points to buried glaciers, remnants from ancient climate phases when Mars had a thicker atmosphere or different tilt, allowing snow or frost to accumulate in areas that are now much drier. This idea connects the cliffs to a bigger pattern, one of shifting obliquity. Unlike Earth, which has a relatively stable axial tilt thanks to its large moon, Mars wobbles over time. These tilts, or obliquity cycles, can dramatically alter the planet's climate. In high tilt periods, the poles receive more sunlight and warmth, while the equator cools. Ice can migrate, evaporate, and recondense in different areas. The ice cliffs may be leftovers from one of these wilder climate swings, frozen proof that Mars hasn't always looked the way it does now. But not everyone sees the cliffs only as natural phenomena. Some observers wonder whether these structures might be part of something more complex. Could the sharply vertical exposures suggest human-like excavation or intervention? Could ancient Martian life, if it existed, have sought out or relied on these formations in some way? There's no evidence to support those ideas, but the symmetry and clarity of the exposed ice walls do invite speculation. Whatever their origin, the ice cliffs mark a powerful moment in Mars exploration, when something precious, something long suspected but rarely seen, was finally confirmed with stark clarity. Not imagined, not theorized, just there, shimmering quietly beneath a skin of red dust. And as scientists began mapping these formations in detail, another layer of intrigue emerged. Some cliffs appeared to be melting ever so slightly at their exposed faces, not flowing as liquid water, but subtly sublimating, changing from solid to vapor in the thin Martian air. It was as if the cliffs were slowly breathing, releasing whispers of ancient water vapor into the atmosphere. That hint of change, that trace of movement, leads us to the next mystery, one that doesn't rest quietly underground, but pulses and fades across the surface itself. Not ice this time, but a pattern of disappearing lines. While those vertical ice cliffs hinted at the frozen remains of Mars's climate history, what lies carved across the surface itself tells an even older tale, one not just of water trapped beneath the soil, but of entire landscapes once shaped by its flow. These aren't subtle hints or pixelated mysteries. They are wide, sweeping features that resemble the kinds of places we know here on Earth, places sculpted by rivers, deltas, and lakes. From the earliest orbital missions to today's high-resolution imaging from NASA's Mars Reconnaissance Orbiter, The evidence has only grown stronger across vast regions of the planet, especially in the southern highlands and low-lying northern plains. Satellite images have revealed massive dried-up riverbeds winding across the terrain like veins. Some stretch for hundreds of kilometers, curving and branching just as rivers do on Earth when they follow the path of least resistance. These aren't jagged cracks or random geological scars. Their shapes suggest they were carved not by slow tectonics, but by moving water, and the rivers seem to lead somewhere. At the ends of many of these channels, researchers found something even more compelling: fan shaped deposits, deltas, where the flow appears to have spread out and deposited sediment into what were likely standing bodies of water. These deltas, found in places like Eberswalde crater and Jezero crater, look eerily familiar. On Earth, they form where rivers meet lakes or seas, dropping silt and sand as the current slows. The presence of Martian deltas implies that these regions once held lakes, possibly long-lasting ones. In Jezero crater specifically, now the landing site of NASA's Perseverance rover, the shape and layout of the ancient delta are unmistakable. You can see the wide inlet where the river once entered, the gentle arc of sediment fanning out into the basin, and the narrow outlet where water may have once drained. Scientists believe this crater likely held a lake for thousands, if not millions of years. That much time with liquid water present, sunlight overhead, and minerals in the soil is more than enough to support microbial life, and Jezero isn't the only place. Gale Crater, explored by the Curiosity rover, also shows signs of once being a lake. Sedimentary layers in the crater walls tell a slow story of water rising and falling over time. The layers form in alternating patterns, some thicker, some thinner, suggesting changing environmental conditions, possibly linked to seasonal rains, dry spells, or even climate shifts. Curiosity has been analyzing these deposits up close, finding clays and sulfates that typically form in the presence of water. Then there's the even larger question: how widespread was this ancient Martian water? Some scientists believe Mars may have once had an ocean covering much of its northern hemisphere. A lower elevation northern basin, when compared to the planet's higher southern terrain, hints at the possibility of an ancient shoreline. Certain features along this supposed boundary, curved ridges, wave-like erosion, add to the speculation. It's not confirmed, but it lingers as one of the planet's most dramatic what-ifs. Could Mars have once looked more like a blue world than a red one? The implications of these ancient riverbeds and lake basins reach far beyond geography. If Mars once had stable, long-lasting bodies of water, then it also had a thicker atmosphere, a different climate, and perhaps a protective magnetic field to hold that atmosphere in place. These are the conditions life would need to begin, and maybe even to thrive. That's why these dry channels matter. They don't just suggest water, they suggest time. Time for chemistry to unfold, for reactions to spark, for microbial ecosystems to take root in the mud. Even after billions of years, if life once existed there, traces might still be buried in the sediment. That's why rovers like Perseverance are collecting samples right now: rock cores, dust particles, and ancient silt, preserved in titanium tubes for a future mission to bring home. And as the rovers crawl across these desolate plains, they pass through valleys that were once riverbeds, across lake bottoms that once rippled with waves. They drive through history, an invisible story written in the land itself. It's hard not to look at these formations and wonder what they would have sounded like back then. Would there have been a breeze across the water? The splash of falling rain? The silence now feels louder, like the planet is remembering something it once held. All of these ancient scars deepen the mystery of what Mars really was, and what it still might be. And if such vast systems of water once shaped the surface, then surely some things, maybe structures, Relics or fossils could have been buried or preserved under that sediment. And that brings us to a place where science fiction and geology begin to blur once more, with a discovery that looks more architectural than natural, a strange rectangular void etched into the rock like a doorway leading into the unknown. While dry riverbeds and lake basins suggest that Mars once flowed with water, a different kind of signal has been stirring beneath its surface, not something seen, but something felt. In 2018, NASA's InSight lander touched down on the Martian plains of Elysium Planitia, not to explore hills or collect rocks, but to listen. Its mission was to place an ultra-sensitive seismometer on the surface, the first of its kind sent to another planet to detect the quiet tremors of Mars itself. And what it heard was stranger than expected. Seismic activity on Earth is common. Our planet is restless, constantly shifting its tectonic plates, generating quakes, eruptions, and grinding faults. But Mars doesn't have plate tectonics the way Earth does. It's considered geologically quieter, colder, and mostly inactive. So when InSight began detecting what NASA would later call Mars quakes, it sent ripples through the scientific community. These weren't the loud, destructive jolts we associate with earthquakes. They were subtle, low frequency rumbles, almost like the planet whispering from deep within. The first Marsquake was detected in April 2019, a soft murmur from beneath the crust. Since then, InSight has recorded more than 1,000 such events, some tiny, others surprisingly powerful. The largest one so far registered in 2022, with enough energy to shake a region the size of a small country. But the real mystery isn't how strong they are, it's where they're coming from and why. Many of the quakes have no clear epicenter. They don't align with any known fault lines. Some seem to originate deep beneath the crust, in areas where scientists expected silence. It's as if something is stirring far below the surface, but not following any of the geologic rules we're used to. And unlike Earth, where quakes are often caused by plates grinding against each other, Mars has no moving plates. That leaves two possibilities. Either something is heating and cracking the crust from within, or something else is shifting underground. Some scientists believe the source could be ancient volcanic zones, slowly cooling and causing the rock to contract and crack. Others suggest buried lava tubes or hidden magma chambers. Remnants of Mars' more active past could be adjusting under pressure. But then there are quakes that seem to happen without warning in areas far from any known geological hotspot. No volcanoes, no tectonic stress, no obvious cause, just sudden, precise jolts, like a footstep in the dark. One particularly eerie discovery came from a pattern of repeating seismic signals, faint tremors that echoed at regular intervals, sometimes from the same region, almost like a pulse. These rhythmic quakes suggest something persistent beneath the surface. Not random, not chaotic, but ordered. Scientists haven't confirmed what's causing them. Could it be a deep cavern collapsing slowly, liquid shifting through hidden underground layers, or even hollow structures that vibrate when pressure builds? InSight's data also revealed that the Martian crust is thinner than expected in some regions and fractured in strange, uneven ways. That fracturing can amplify certain quakes and muffle others, giving researchers clues about what lies below. In some zones, the vibrations seem to bounce oddly, as if the land is concealing chambers or cavities. There's no direct evidence yet, but the unusual way some seismic waves travel, bending, echoing, or splitting, hints at gaps or voids under the surface that standard models can't explain. These seismic whispers don't just tell us about Mars's past, they hint at what it might still be. A planet that hasn't gone completely quiet, a world that shifts in the dark, revealing secrets only if we're listening closely enough. Even when InSight's solar panels grew dusty and the mission wound down, Its seismometer kept capturing these deep hidden sounds, the final heartbeat of a silent observer tuned to the voice of another world. And it wasn't just tremors that stood out. Occasionally, the lander recorded vibrations that came with no quake, soft, sudden movements that didn't behave like any seismic event. Some were too shallow, too brief, or too isolated. Could they be meteor impacts striking the surface and sending shock waves through the crust, or perhaps something beneath, adjusting, echoing? As Mars continues to hum with its own subtle energy, researchers are left with more questions than answers. Insight gave us a stethoscope pressed against a planet's chest, and what it heard was not silence, but signs of life beneath the crust, even if not biological. And now, having listened to what lies below, our attention shifts to something even older, embedded not in sound, but in the very makeup of the Martian surface. Because just beyond these trembling plains lie stones that shouldn't be there, metallic shapes, strange outlines, and the eerie suggestion of fragments that look manufactured. After listening to Mars's seismic whispers, the subtle tremors that pulse beneath its crust, the curiosity deepens, not just in what Mars hides below, but in what it reveals on its surface. And perhaps no single image has stirred the imagination more than what came from the Cydonia region in 1976. The photograph snapped by NASA's Viking 1 orbiter, just one of many it was taking as it mapped Mars from above, showed something so unexpected, so eerily familiar, that it captured the world's attention like no other Martian mystery had before. There, in the middle of the dusty, windswept plains of Cydonia, a massive landform sat motionless under the golden Martian sun. But this wasn't just another rocky hill. The image showed what looked uncannily like a human face, complete with deep-set eyes, a nose, a mouth, and even what appeared to be a headdress or crown-like feature surrounding the head. It was enormous, over 2 kilometers long and nearly a kilometer wide, carved naturally, or perhaps unnaturally, into the Martian landscape. When NASA first released the image to the public, they labeled it as a rock formation and even joked about the resemblance. But to many eyes, it looked far too deliberate to be chance. Almost instantly, the face on Mars became a worldwide sensation. For years, people had dreamed of intelligent life beyond Earth, of civilizations lost in time or living just out of reach. Now, here was what seemed like a monument, gazing upward from the surface of another planet, as if it were waiting to be found. Writers, researchers, and theorists pored over the image, highlighting symmetry, shadows, and proportions. Some pointed out that the features of the face followed classical artistic ratios, the same ones used in sculptures on Earth. Others claimed that nearby formations in Cydonia resembled pyramids or even a ruined city grid, suggesting that the face wasn't alone, but part of something larger, something built. For many, this wasn't just imagination, it was evidence, or at least the beginning of something that could rewrite how we understand Mars and our place in the universe. The possibility of ancient civilizations, ones that perhaps died out or left clues behind, gained new momentum. Books were written, documentaries aired, and debates raged between skeptics and believers. The face wasn't just a rock anymore, it had become a symbol, a question carved in stone. But science kept marching forward, and with better cameras and more advanced orbiters, NASA returned to Cydonia in the early 2000s with sharper eyes. The Mars Global Surveyor, and later the Mars Reconnaissance Orbiter, equipped with the powerful high-rise camera, captured the same mesa in much higher resolution. And what those images showed looked different. From a clearer angle, with improved lighting and resolution, the structure lost much of its facial detail. It now looked like what NASA had claimed all along, an eroded rock formation, shaped by wind and light, casting shadows that just happen to fall in ways our human brains interpret as familiar. Scientists called it pareidolia, a psychological phenomenon where the brain sees patterns in randomness, like seeing animals in clouds or faces on toast. From that view, the face on Mars became a cautionary tale in how easily the mind can turn shadows into stories. To the scientific community, it was explained, resolved, and set aside, but not everyone accepted the updated version so easily. Many people still point to the original Viking image as the most compelling. They argue that the later photos were taken at different angles, under different lighting, or that something changed in the years between. Some even suspect image tampering, a claim NASA firmly denies. And even if it is just a trick of light and erosion, the question still lingers in the imagination. Why does this one hill, on this vast and empty planet, so perfectly resemble a human face? Perhaps it's coincidence, or perhaps it's a marker, not of alien life, but of how deeply we want to find it. That face staring back at us through the dust may be just a mirror, reflecting our hopes, our patterns, and our search for meaning in the void. But the Cydonia mystery doesn't end with the face. Nearby, satellite images have revealed other formations that raise similar questions: sharp triangular mounds with matching angles, shadowy depressions that resemble entrances or collapsed tunnels. Are they just rocks, shaped by ancient winds? Or is Cydonia a region where Mars whispers louder than anywhere else? As the orbiters pass overhead and the rovers continue their crawl across the surface, the face remains, not as proof, but as provocation, a moment when Mars looked back, and as we continue forward, the path leads toward even stranger shapes and sharper questions. Because the surface of Mars holds more than echoes. In some places, it appears to hold pieces, fragments, things that don't belong. The face on Mars wasn't the only thing watching from the Cydonia region. While most people fixated on the humanoid features etched into that mesa, a quieter but equally strange discovery sat nearby. Less obvious at first glance, but no less unsettling once noticed. Scattered across the same Martian plain were other formations, eerily geometric in shape, jutting from the dust like forgotten monuments. Some were triangular, with surprisingly even angles. Some looked like 3 or 4 sided pyramids, partially buried or worn down by time. When viewed from orbit, they didn't resemble natural chaos, they resembled design. One of the most discussed examples is a formation called the DNM Pyramid, named after researchers Vincent DiPietro and Gregory Molinar, who were among the first to bring attention to these Martian anomalies. The DNM structure, based on early Viking imagery, appears to have 5 sides, sharply defined, with straight ridges that taper to a point. At first glance, it almost mimics the pyramids found in Egypt or Central America, except this one rises not from jungle or sand, but from an alien terrain nearly 200 million kilometers away. Not far from the DNM structure is another mound, dubbed the Fortress by observers, which some describe as having a squared base and rampart-like extensions. Then there are smaller mounds, almost symmetrically placed, that some have claimed align in a specific geometric pattern. A few independent researchers even suggested they form a pentagonal grid, too precise, they argued, to be coincidence. That's where the speculation deepens. Some believe these structures, together with the face on Mars, form a deliberate layout, as if they were designed to work together, not unlike the ancient complexes humans built on Earth. On our planet, civilizations like the Egyptians, the Maya, and the Sumerians aligned monuments with stars, solstices, and sacred geometry. If ancient Martians once existed, or some other force shaped the surface with intention, would they not do the same? It was this pattern hunting that ignited widespread debate in the late 20th century. Books and documentaries poured in. Diagrams of the so-called Cydonia complex were drawn and redrawn, connecting dots between the face, the D&M pyramid, the fortress, and the surrounding hills. Enthusiasts pointed to their spatial relationships, claiming mathematical precision, golden ratios, right angles, mirrored layouts that nature supposedly wouldn't produce on its own. NASA, for its part, has always approached these claims with caution and a strong dose of skepticism. With more advanced satellites like Mars Global Surveyor and the Mars Reconnaissance Orbiter, scientists were able to obtain much sharper images of these landforms. From their point of view, the features lost much of their symmetry and mystery. What once looked like a perfect pyramid now appeared more like a jagged hill. Erosion, lighting, and the human brain's tendency to find patterns where none exist. These were the go-to explanations. They pointed out that Mars is covered with buttes, mesas, and eroded mountains formed by billions of years of wind, dust, and volcanic activity. Given enough time and the right lighting, some of those rocks are bound to look familiar, even intentional. From orbit, the brain can turn anything into something else. Faces, pyramids, cities. It's the same reason we see bunnies in clouds, or smiley faces in electrical outlets. Pareidolia, they said, is far more likely than ancient architects. But not everyone was convinced. Some argue that NASA's explanations are overly dismissive, that they ignore the bigger picture. While it's true that erosion can sculpt some remarkable shapes, how many pyramids, how many symmetrical lines, and how many alignments does it take before coincidence becomes something more? The skeptics ask, if these shapes were found on Earth, triangular mounds aligned with each other, positioned near something that looks like a human face, would we immediately assume they were natural? Or would we start digging, mapping, studying? Some say that we're too quick to explain away Martian mysteries because the alternative is too vast, too uncomfortable. It's easier to believe it's just rocks than to wonder if we're seeing ruins. The atmosphere around Cydonia remains thick, not with weather, but with doubt. It's a region full of shadows where every angle casts a new question. And even if the face has faded under better resolution, and the pyramids don't look quite as sharp in modern images, there's something about the layout that refuses to settle, a kind of quiet symmetry that lingers just under the surface. What if we're not looking closely enough? What if our instruments see clearer, but our curiosity has blurred? Because even now, decades after Viking 1 first snapped that haunting image, Cydonia continues to be the part of Mars people come back to, not because it gives answers, but because it never quite lets go of the questions. And just beyond Cydonia, across other dusty plains, Mars has more strange shapes to show, objects that don't resemble pyramids or faces, but fragments, things that look like they never belonged on a barren, windswept world in the first place, things that resemble machines. Far from Mars's more familiar dusty plains and rocky ridges lies a region that seems pulled from an ancient blueprint, an architectural mystery etched into the ice-covered terrain near the planet's southern pole. This area, nicknamed the Inca City, doesn't immediately look like the chaotic surface features we've come to expect from Mars. Instead, what jumps out from orbital images is order lines, angles, and shapes that seem almost organized. It was first spotted in 1972 by NASA's Mariner 9 mission, the first spacecraft to orbit another planet. As it scanned the Martian surface and transmitted back thousands of images, one of them stood out. In the lower latitudes near the South Pole, scientists saw something startling, a formation made of straight grid-like ridges forming rectangular patterns, almost like the remains of old stone walls or the layout of a forgotten city buried under dust and frost. The area was eventually dubbed Inca City because of its resemblance to ancient Incan ruins on Earth, places like Sacsayhuaman or Machu Picchu, with their stone blocks and repeating lines. To the untrained eye, the resemblance is uncanny. From above, the crisscrossing walls of the Martian formation almost look like city blocks or the outline of a fortress. But this is no urban sprawl. It's isolated, remote, and appears to be made from intersecting ridges that rise above the surrounding terrain in a strange angular symmetry. The scientific community, cautious as ever, offered a more grounded theory. They proposed that these rectilinear features were caused by natural erosion, specifically erosion tied to CO2 frost cycles. In this part of Mars, temperatures drop so low that carbon dioxide from the atmosphere can freeze directly onto the surface, forming frost layers and ice slabs. As the frost sublimates, turning from solid directly into gas, it can crack the underlying terrain, especially if it's made up of layered sediments. These cracks can grow over time into polygonal fractures or straight line ridges. It's a theory grounded in real Martian processes. CO2 frost is a seasonal phenomenon on Mars. During the long Martian winter, large amounts of this frost coat the southern polar region. As spring approaches and sunlight returns, this frozen CO2 doesn't melt in the way water does on Earth. It instead sublimates, transitioning into vapor. This rapid phase change can cause surface material to fracture and shift, creating fissures, ridges, and even small collapses. But the shape and precision of the Inca City formation still raise questions. While polygonal cracks are common in permafrost regions on Earth, and even on Mars, these particular ridges aren't haphazard, they're nearly straight. They intersect at near right angles, and most curiously, they repeat. The repeating block-like pattern spans an area several kilometers wide, far more structured than most frost-sculpted terrain we know. Some researchers have suggested that these formations could be the remains of ancient fault systems, tectonic cracks in the Martian crust that were later accentuated by frost erosion. Others believe they might be the exposed remnants of a buried dike system, underground channels of solidified magma that formed long linear walls of resistant rock. Over time, wind and frost would wear away the softer material around them, leaving behind the hardened grid we now see. But even with these natural explanations, the human brain struggles to dismiss the visual impact. There's something about straight lines that triggers recognition in us. On Earth, nature prefers curves, irregular angles, and chaotic formations. But straight lines, right angles, repeating rectangles, these usually mean one thing: intelligent design. It's how our minds are wired. From crop fields to city streets, our civilizations have been built on order. So when we see a grid on another planet, especially one as barren as Mars, it's hard not to wonder. The debate continues. Most planetary scientists support the natural erosion hypothesis, citing similar though less dramatic examples on Earth's polar deserts and even in the frozen terrain of Antarctica. But some observers, especially those outside mainstream academia, keep pointing to the overall layout. Why here? Why so symmetrical? Why does it remind us so strongly of something ancient, deliberate, and long abandoned? Adding to the intrigue is the fact that this region of Mars is difficult to study in detail. Its position near the South Pole means it's shrouded in frost for much of the Martian year. The thin atmosphere and seasonal lighting conditions make high-resolution imaging a challenge. That means many of the finer features of Inca City remain blurry or obscured, even with modern orbiters like the Mars Reconnaissance Orbiter. Still, NASA has taken follow-up images, and while some details have become clearer, the overall mystery has only deepened. The more we look, the more it feels like this place wasn't shaped by chaos, but by some strange order, either geological or, as some quietly speculate, artificial. And if formations like Inca City make us question nature's limits, What follows may shake those limits even further, because scattered across the Martian surface are objects that don't look like rock at all, some of them round, others metallic, a few impossibly precise. Objects that resemble debris, remnants, or components, as if something once worked, moved, or even lived here. High above the rust colored plains of Mars, two tiny moons orbit in silent loops. One of them, Phobos, is especially strange. It's small, barely 22 kilometers wide, shaped more like a jagged potato than a perfect sphere. Its surface is battered, lifeless, and ancient. But there's one feature that stands out from the rest: a tall, light colored monolith jutting up from the ground, all alone, casting a long, unnatural shadow. A solitary structure on a forgotten moon, and no one truly knows how it got there. It was first noticed in photographs taken by the Mars Global Surveyor in the late 1990s. Among the chaotic surface of craters and debris, the monolith stood upright, an obelisk like boulder estimated to be about 85 meters tall, which is nearly the height of a 25-story building. What made it even more striking was its isolation. It wasn't part of a cluster, it wasn't surrounded by similar features. It stood alone on the relatively flat terrain of Phobos, sticking out in a way that made scientists, space agencies, and the public stop and ask, "What is that?" The term monolith caught on quickly. It didn't mean it was a real monolith in the alien sense, just that it was a large, upright stone. Still, the name itself brought with it a sense of mystery, especially to those who remembered the famous black monolith from 2001, A Space Odyssey, which triggered profound leaps in intelligence for early humans. The resemblance in shape and eerie placement stirred imaginations across the world. Then came the quote that lit a fire under the mystery. In 2009, during an interview on C-SPAN, Apollo 11 astronaut Buzz Aldrin, known for being the second man to walk on the moon, spoke about the Phobos monolith with unexpected intensity. He said, "We should go there. We should visit the moon of Mars. There's a monolith there, a very unusual structure on this little potato-shaped object that goes around Mars once every 7 hours. When people find out about that, they're going to say, 'Who put that there? Who put that there?' That wasn't a science fiction writer or a conspiracy theorist. That was Buzz Aldrin, a man who had seen space up close and returned with a voice that still carried weight in scientific circles. His statement echoed across headlines, reigniting public curiosity. Was it just a rock or something more? NASA has not officially labeled the structure as anything unnatural. The leading explanation is that the Phobos monolith is a chunk of native rock, possibly from a nearby impact that rolled or was ejected onto the surface and happened to land upright. On a low-gravity moon like Phobos, which has almost no atmosphere and only a fraction of Earth's gravity, strange geological behavior is expected. A boulder that might roll down a hill and come to rest horizontally on Earth could just as easily end up sticking out vertically on Phobos. Still, the odds of it landing that perfectly alone, tall and upright, are slim enough to give anyone pause. Even more curious is Phobos itself. The moon orbits just 6,000 kilometers above the Martian surface, closer to its planet than any other moon in our solar system. It orbits faster than Mars rotates, rising in the west and setting in the east 3 times a day. And it's not stable. Its orbit is decaying slowly, and within the next 30 to 50 million years, it's expected to either crash into Mars or break apart into a ring. Some scientists even debate whether Phobos is a captured asteroid or a piece of Mars that broke off long ago. Its composition is strange, dark, porous, and inconsistent, leading to speculation that it may be hollow or partially artificial. Those ideas have largely been dismissed by the scientific mainstream, but not entirely. In 2010, Russian scientist Dr. Iosif Samuilovich Shklovsky proposed that Phobos might be a hollow object, though he framed it as a theoretical discussion more than a claim. The idea was controversial, but it lingered. Add a towering monolith into the mix, and suddenly Phobos feels less like a moon and more like a riddle. The monolith remains unvisited. No mission has landed on Phobos yet, though several have tried. Russia's Phobos Grunt mission in 2011 aimed to collect samples from the moon's surface, but failed shortly after launch. Other space agencies have floated the idea of returning, NASA, ESA, and JAXA among them, but so far, the Phobos monolith continues to stand in silence, untouched. What it really is, just a lonely boulder or something stranger, remains unanswered. What's certain is that it exists, it's real, you can see it in official images, and its eerie presence raises deeper questions. If nature alone placed it there, how many other places across the solar system hold similar surprises? What might we still find, buried beneath the dust or orbiting in the shadows? And as we leave Phobos behind, attention turns once more to Mars itself, because just beyond its red horizon lies a region where pyramids, faces, and ancient looking formations seem to whisper of something lost. Beneath the dusty red skin of Mars, something stirs, or at least something hides. As rovers crawl across the surface and orbiters capture sweeping aerial views, scientists have begun peering deeper than ever before, not with shovels or drills, but with thermal eyes. And what these eyes are revealing has ignited new waves of curiosity, hidden shapes beneath the Martian soil, some of them shockingly geometric, perfect rectangles, linear alignments, thermal signatures that don't match the random chaos of nature. This chapter of Martian mystery unfolds through a quiet but intriguing technology, thermal imaging. Orbiters like the Mars Odyssey spacecraft are equipped with instruments such as the Thermal Emission Imaging System, THEMIS. These sensors detect infrared radiation, basically heat, by measuring how different parts of the Martian surface absorb and release warmth. THEMIS can help build a picture not just of what we see on the surface, but of what might be underneath. Over time, scientists started to notice patterns. In several locations, when the sun sets and the Martian night takes over, the ground cools down, but not evenly. Some areas release heat faster, others retain warmth longer than expected, and in a few curious spots, the shapes holding that heat look suspiciously regular. At first, these were dismissed as geological quirks, maybe denser rock, maybe patches of soil with higher salt content. But some of the anomalies were large, deeply embedded, and most intriguingly, rectangular, not rounded like natural formations usually are, not chaotic like wind sculpted dunes, but long, straight edges and sharp angles beneath several feet of dust and sediment. One example came from scans near the Arabia Terra region, a landscape already known for strange erosion and ancient sedimentary layering. Here, the subsurface thermal signature appeared in a perfect block, completely misaligned with the surrounding terrain. It didn't erode like a hill. It didn't sprawl like a dune. It looked, for lack of a better term, placed. Other anomalies turned up near Elysium Planitia and Noctis labyrinthus, in areas already considered geologically complex. In those cases, thermal mapping revealed linear features beneath the regolith, features that held heat longer than their surroundings and extended in unnaturally straight lines for dozens of meters. Could they be buried walls, ancient foundations, underground voids where something once stood? Of course, NASA has been careful with its language. The official line is cautious. These anomalies could be explained by natural layering of different rock types or by temperature variations in ice-rich ground. In colder regions such as Mars's mid-latitudes and poles, frozen subsurface water could trap heat differently than dry soil. When asked, many planetary scientists suggest these are likely permafrost features, or maybe the result of ancient lava flows creating dense, flat subsurface rock. The consensus, at least publicly, is that these are probably geological, not architectural. But speculation won't go away, especially since these shapes aren't always aligned with known geological forces. They don't follow the slope of terrain, they don't match with wind erosion patterns, and perhaps most importantly, they don't appear in random arrangements. In a few areas, the anomalies seem to repeat, clustered together in ways that some researchers argue resemble layout grids. Not just one rectangle, but several, lined up like city blocks. Naturally, this has fueled the imagination of independent researchers, anomaly hunters, and amateur sleuths across the globe. They argue that if an intelligent species once lived on Mars, or even visited it, these could be the foundations of their settlements, now buried under millions of years of dust storms and climate shifts. Some go further, suggesting these thermal signatures may hide hollow structures beneath rooms, chambers, vaults that have yet to be accessed. Still, the instruments can only see so much. THEMIS and other thermal imagers detect temperature differences just meters below the surface. They don't provide clear visuals like an X-ray. It's more like detecting a hand pressed behind a curtain. You see the outline, you feel the heat, but you can't confirm the identity. What makes the mystery more tantalizing is that despite the buzz around these shapes, NASA and other space agencies rarely follow up with targeted exploration. With limited rover mobility and mission constraints, the focus remains on broader geological questions: water, climate, habitability. That leaves many of these strange heat maps unexamined, filed away in raw data, waiting for a day when technology or mission priorities catch up. And that's where the intrigue deepens. Because if we don't explore them, they remain unanswered. If they're just ice, fascinating. If they're ancient buildings, history shattering. But until someone goes there, digs, and looks beneath the veil, all we have are blurry heat signatures, suspiciously perfect shapes, and a rising chorus of questions. And as we leave these mysterious patterns underfoot, Mars continues to offer new puzzles, including sounds that don't belong, recorded tremors that echo from underground, and vibrations that whisper of something shifting in the deep. As curiosity slowly made its way across the dusty surface of Gale Crater, one particular image sent shockwaves through the online world. A solitary rock, half buried in sand and shadow, appeared to be staring back, empty eye sockets, a sloped brow, a rounded cranium. It looked unmistakably like a skull, a human skull, or at least something eerily close. The photo, taken by Curiosity's Mastcam, went viral within hours. Forums lit up, YouTube videos analyzed every pixel, and headlines posed the question that had hovered around Mars for decades: did something once live here? The official name for what happened is pareidolia. It's a psychological phenomenon where the brain tries to find familiar patterns, especially faces, in random images. We see animals in clouds, faces in tree bark, and now skulls in Martian rocks. According to scientists at NASA, this was just another case of pareidolia, amplified by lighting, camera angle, and our very human desire to make sense of chaos. The rock, they explained, was roughly the size of a baseball and most likely formed by normal erosion processes shaped by wind, dust, and time. But even if that's true, the image was hard to dismiss. The resemblance was too close. There were ridges that looked like nasal cavities, a slight jawline, and perhaps most unsettling, the emptiness of it. On a planet where nothing moves, where silence stretches for miles, here was a face looking back. Skeptics were quick to point out that the scale alone ruled out anything extraordinary. No, this wasn't the remnant of an ancient humanoid creature. No, it wasn't fossilized bone. It was a rock, plain and simple. But believers, or at least the Mars curious, weren't so easily convinced. What if the size didn't matter? What if it was a symbol or a relic of something else entirely, something we don't yet understand? The debate grew even louder when side by side comparisons began circulating. Images of human skulls next to the Martian rock. The contours matched, the shadows matched. And that's all it took for the conversation to spread. Some argued it could be an alien artifact, a statue, a memorial, a marker left behind by a civilization long gone. While there's no hard evidence for any of this, history shows us that major discoveries often begin with strange coincidences, a bone sticking out of a cliff, a pattern spotted from afar. On a world as unexplored as Mars, even the smallest anomaly invites big questions. And this wasn't the first time a formation on Mars had been mistaken for something familiar. But this one struck a nerve. Maybe it was the primal imagery of the skull, a universal symbol of life and death. Or maybe it was because it looked so intentional in its shape, like something carved and left to be found. What makes the story even more intriguing is how NASA handled it. There was no official press release, no deep analysis or public breakdown. The image was added to the ever growing archive of raw curiosity data, free for anyone to explore, but not emphasized. That silence led many online communities to wonder if something more was being left unsaid. And then came the theories, some wild, others surprisingly thoughtful. One proposed that the rock's shape could be the result of ancient Marsquakes fracturing softer material in just the right way, then slowly being sculpted by the harsh winds of the Martian atmosphere. Another theory suggested this was a piece of debris ejected from a now buried structure or cave system. If underground chambers had collapsed, what might they have pushed out into the open? A few even tied the image back to the recurring theme of Martian pareidolia. How over the years we've seen rats, lizards, tools, and now faces in rocks. Could all of these be coincidental? Or was there a pattern we were missing? A mosaic of fragments hinting at something larger, scattered across the surface and waiting to be pieced together. Of course, most scientists urge caution. Seeing patterns doesn't make them real. But they also admit that the brain's tendency to seek meaning is what drives exploration in the first place. We didn't build telescopes and send robots to other worlds because we knew we'd find something. We did it because we hoped we might. And so the skull-shaped rock remains, not just on Mars, but etched into the imagination of Earth. A tiny formation in a sea of dust, elevated by chance and curiosity into a symbol of mystery. Whether it's just another rock or the first piece of a much bigger puzzle, it reminds us that the red planet still has secrets. And just around the next bend, curiosity might stumble across the next one. Scattered across certain images captured by rovers on Mars, particularly from Curiosity and Opportunity, are formations that don't quite fit the usual rocky, barren expectations of the red planet's surface. They don't rise like mountains or sprawl like canyons. Instead, they reach out, thin, branching, delicate, almost like tendrils, almost like the roots of a tree. These structures have sparked fascination not because of their size, but because of their form. In multiple high-resolution images, you can see them stretching along the surface of flat rocks or emerging from within fractured stone. They resemble fibrous strands, gnarled and tangled in places, yet too precise to be completely random. Some appear to follow a central vein, splitting off like branches, while others seem woven together in a web-like pattern. At first glance, They seem unmistakably biological. They mimic the architecture of plant roots or fungal mycelium, especially when seen in silhouette under Martian light. Their shapes echo the natural design we associate with living systems: repetition, branching, purposeful spread. But this is Mars, a place we have yet to confirm ever supported life. So, what are these root like structures doing here? NASA scientists have offered a few possibilities. One of the most discussed explanations is that these are mineral veins, where fluids once moved through the rock, depositing different materials like calcium sulfate, which then hardened over time. These veins, formed deep underground, could have been exposed as erosion peeled back layers of Mars's ancient surface. On Earth, we see similar patterns in places like the Mojave Desert or Antarctica's dry valleys, where mineral rich water once carved delicate pathways into stone. Another possibility is crystallized salts. Mars is known to have high salt content in its soil and subsurface layers. If briny water ever flowed across or beneath the surface, it might have left behind these strange formations as it evaporated, structures that look alive but are, in reality, purely chemical in origin. This explanation seems plausible, especially in light of the planet's known chemistry. Still, it doesn't quite capture the eerie symmetry seen in many of these fibers. To those outside the scientific community, the everyday observers and enthusiasts poring over publicly released rover images, the visual resemblance to biological systems is difficult to ignore. In some cases, the branching is so fine, so consistent, that calling it just mineral feels like brushing off a whisper from the unknown. It's the kind of image that forces people to stop scrolling and stare, to ask, is this really just geology? There's also the question of where these structures are found. Many appear in fractured rock, suggesting they might have grown or formed within cracks. On Earth, this is exactly where plant roots and fungal filaments take hold, inside moist, sheltered spaces that allow them to feed and expand. That parallel only deepens the mystery. Could Mars once have had the right conditions for something similar? And if so, what happened to it? Compounding the intrigue is the lack of follow up. Unlike larger anomalies, like massive cliffs of exposed ice or glowing streaks on Martian slopes, these tiny fiber like formations haven't been the subject of major press releases. They're often buried in raw image dumps left for amateur sleuths and citizen scientists to uncover. No official explanation has definitively labeled them one thing or another. They sit in a gray zone, not dramatic enough to be declared a breakthrough, yet too unusual to be dismissed outright. Some speculate they might be fossilized traces of ancient life, microbial colonies that once grew in Martian soil and left behind these root like imprints. Others suggest they could be evidence of biomineralization, a process where living organisms help form minerals in complex structures. On Earth, certain bacteria and algae do just that, creating filaments that later fossilize in rock. If anything like that ever existed on Mars, these structures could be the echoes. Still, skeptics hold firm that pareidolia, that same pattern seeking trick of the brain, might be at work again. When you're looking for life, your mind will try to find it, even in places it doesn't exist. They argue that erosion, crystallization, and natural fracturing are more than enough to explain what we're seeing, but what remains undeniable is that these structures are a puzzle. Whether they're the outcome of Martian weathering or something more, they push the boundaries of what we expect from a planet we're still getting to know. And they're not alone. Across countless images, hints like these appear, fleeting, fragile, and often ignored. And as curiosity continues to crawl forward, taking photo after photo, it's possible that even stranger shapes will surface. Not grand monuments or ancient machines, but the subtle, delicate fingerprints of a planet that refuses to be fully understood. Half buried in the Martian sand, Just beneath a small slope captured by the Curiosity rover lies an object that has stirred more speculation than most. It doesn't sprawl like a boulder or fragment like shattered rock. Instead, it appears intentional, a clean cylindrical shape, smooth, even, and oddly precise. It juts out from the soil at an angle, as if something once moving or standing upright had fallen and been slowly consumed by time and dust. This image, taken not far from Gale Crater, would go on to become one of the most widely shared rover photographs ever released. What made it different wasn't its size. The object itself is relatively small, no longer than a hand, maybe less, but it's the shape that made people pause. Unlike the jagged rocks and dusty fragments that dominate Martian terrain, this piece looked engineered, a uniform tube with even edges and a slightly flattened side, almost like piping or a segment of something larger. The shadows cast by the Martian sun gave it depth, and to many the image seemed to whisper, "This doesn't belong here." NASA offered a cautious explanation. Their team suggested it was likely a natural rock formation, possibly a broken piece of harder material that resisted erosion differently than the surrounding stone. On a planet shaped by billions of years of wind, impacts, and shifting temperatures, even the strangest shapes can arise by chance. Still, the cylinder stood out. Its clean lines didn't look fractured, they looked deliberate. Zooming in on the photo, online communities dissected every pixel. Some noted a small lip along the edge like a seam. Others pointed out the way the cylinder's surface caught the light, not with the gritty texture of most Martian rocks, but a strange smoothness, almost metallic in places. A few users applied filters to enhance the contrast, trying to bring out any markings or hidden patterns. Some believed they saw grooves, suggesting threading or manufacture. Others swore it resembled a piece of tubing, the kind you'd find in an engine or a fluid system. Speculation grew rapidly. Was this part of a crashed probe? A remnant from a past mission? But Curiosity had not landed anywhere near known debris from older spacecraft, and no mission before had placed hardware in that exact region. The possibility that this was Earth originating seemed increasingly unlikely. That left only two options in the minds of many: a strange rock or something much older. Ancient artifact theories exploded online. The cylinder became the centerpiece of dozens of videos and forums. Some drew comparisons to pipe fragments unearthed in early human settlements on Earth, suggesting Mars too might have hosted builders. Others speculated about buried ruins, claiming the object was just the tip of something buried beneath the sand. A tower? A conduit? A container? Theories ran wild. And while mainstream scientists remained grounded, the cylinder was never formally investigated in depth after the photo. Curiosity, limited in both time and tools, moved on to other mission objectives. There was no second photo of the same spot from a different angle, no robotic arm analysis or chemical scan. The object became a question frozen in place, its details preserved in a single frame. This lack of follow up only added fuel to the mystery. If it were just a rock, many asked, why not confirm it? Why not examine something that captured so much attention, not just from the public, but from planetary geologists who also admitted the shape was unusual? Some believed NASA didn't want to stir further curiosity. Others saw it as an oversight, one more mystery left behind, as Mars demanded answers elsewhere. But what the cylinder truly revealed, beyond its physical form, was how quickly we recognize design. Our brains are wired to spot patterns, purpose, and symmetry. And when something appears built, even in a place as lifeless as Mars, we pay attention, not because we assume little green men, but because shape matters. Intent leaves traces. And this trace didn't feel random. As more missions explore Mars, and as future rovers gain better tools, drills, spectrometers, even sample return systems. Perhaps we'll revisit these anomalies. Perhaps one day someone will dust off that buried object and finally say what it is. But until then, the cylinder remains where it always was, half submerged in the red dirt, half submerged in the human imagination, quiet, motionless, and stubbornly unexplained. And just ahead, along another dune, and beneath another shadow, something even stranger waits to be found. Near the base of a windswept hill in Gale Crater, the Curiosity rover captured a photo that would spark debate not because of what it revealed, but because of what it resembled. Sitting quietly in the Martian dust was a small flat rock with an uncanny shape, one half folded over the other, like stiff pages, with a central seam so precise it seemed sculpted. It looked exactly like an open book, lying face up, waiting to be read. Its cover appeared firm and square edged. The pages layered beneath showed a clear, clean break, almost like something once bound had come loose. The image was simple but arresting. There was no dramatic background, no strange lighting, just this one rock sitting in the dust, shaped so neatly and so perfectly that even seasoned scientists did a double take. NASA geologists, always cautious in their language, explained that the object was most likely the result of sedimentary layering. Mars, like Earth, has a long geological history involving wind, pressure, and time. Layers of sediment pile up and compress into stone, sometimes breaking along fault lines or erosion patterns. In this case, they said, wind likely eroded the edges of a layered deposit, causing a flat fracture that left behind a fold like appearance. A coincidence, yes, but not a mystery. But many weren't convinced. To those outside the official explanations, the book rock seemed too exact. The fold had a symmetry that didn't match the randomness usually seen in erosion. The angles were sharp. The top layer curled with just enough arch to suggest intentional design. It was almost theatrical in its stillness, like a forgotten sculpture in a desert library. Zooming in, amateur analysts highlighted what appeared to be parallel ridges across the pages, adding to the illusion. Some argued it looked like text or etchings, faded by time but still present in faint, deliberate lines. Others dismissed this as pareidolia, the tendency of the human brain to find meaningful shapes in random patterns. Still, even those quick to embrace science had to admit this rock was peculiar. What added fuel to the conversation was how often Mars surprises us with shapes like this. Earlier images had shown what looked like a fossilized femur, a spoon suspended mid-air, and fragments shaped like bolts and pipes. But the book struck a chord because of its quiet symbolism. Books are human, they are intentional, they represent knowledge, memory, and culture, all things we don't associate with a barren alien world. The uncanny resemblance also raised a deeper question. How do we know what is artificial? On Earth, design often means repetition, symmetry, and function. When we see straight lines or folds, we instinctively link them to intelligence, to planning and structure. But on Mars, where we have no known history of civilization, anything that hints at those features becomes a point of tension. Either it's just nature showing off, or it's something more. For now, the book rock sits undisturbed, its secrets preserved in stillness. Curiosity did not linger long enough to take further samples or probe beneath its surface. There was no chemical analysis or closer scan. The photo, like so many others, became one more file in the growing Martian gallery of unexplained geometry. It's also worth noting that this isn't the only time layering has created strange illusions on Mars. In other areas, erosion has sculpted rocks into near perfect cubes, thin fins, and even a shape resembling a doorway carved into a cliff. NASA has explained most of these as results of fracture patterns, wind erosion, and freeze-thaw cycles over millions of years. And perhaps they are right, but there's a line between randomness and replication, and every so often an image crosses it, forcing us to pause. The book sits right on that line, and like any good story, its meaning depends on the reader. Scientists see geology, artists see metaphor, skeptics see coincidence, dreamers see possibility. But what remains undisputed is the power of that image. One rock, shaped just so, reminds us that Mars still holds the power to mimic the familiar in the midst of the unknown. And further along Curiosity's path, beyond this solitary book-shaped stone, another object waited in the sand, stranger still, not layered, not fractured, but growing in threads that resemble something alive, not fractured, but growing in threads that resemble something alive. Scattered across the cold plains of Mars, as far as the eye can see, lies a strange and silent geometry carved into the ground itself. These aren't towering rocks or weathered monuments. Instead, they're subtle, etched directly into the surface, like a language only nature could write. From orbit and in rover imagery, they form a mesmerizing lattice, hexagons, pentagons, and polygonal shapes that fit together like pieces of a jigsaw puzzle with no missing parts. Known as polygonal patterned ground, these geometric formations stretch across vast areas of the Martian terrain. Some appear tight and dense, their shapes interlocked like a honeycomb. Others are more spread out, with shallow ridges tracing almost perfect borders around each polygon. At first glance, they look eerily artificial, like someone had drawn them into the surface with a colossal compass. But no human hands have ever touched this land. So what's behind the pattern? Most scientists believe these designs are the result of freeze-thaw cycles. On Earth, similar patterns are found in the Arctic and Antarctic regions, places where frozen ground cracks as temperatures fluctuate, and water or ice expands and contracts. The cracking typically forms a network of polygons as the stress distributes evenly across the surface. Over time, fine materials settle into the cracks, creating raised or sunken edges that outline the shapes more clearly. On Mars, the same principles likely apply, but with one key difference. The ground here is far colder, far drier, and it has been untouched for millions of years. What makes the Martian polygons so fascinating isn't just their size, some span several meters across, but their precision. The angles are sharp, the edges consistent. Some regions look as if the shapes were laser etched, so regular and smooth are the divisions. It's this regularity that raises eyebrows. While Earth's patterned ground often looks chaotic or interrupted by plant life or terrain changes, Mars's patterns remain crisp and uninterrupted, sometimes covering entire valleys in symmetrical tiles. The polygons are also unusually widespread. They're found not just in one area, but across different latitudes and elevations, from low-lying plains to crater floors. Some occur in regions where no water ice is visible at the surface, suggesting that something might be shifting underground, perhaps hidden ice, slowly sublimating, or ancient frozen material still reacting to seasonal temperature changes. Then there are places where the polygonal shapes look almost raised, like ridges or walls, while in others they're sunken depressions. This variation has led some researchers to speculate that not all polygon patterns on Mars are formed by the same process. Some could be permafrost cracking, others might involve subsurface gas or dust dynamics, and still others remain unexplained. The patterns are so visually compelling that many observers have nicknamed them crop circles of the Martian tundra. Like crop circles, their symmetry and scale spark curiosity and occasionally conspiracy theories. The mind naturally wonders, if nature is responsible, how can it be so exact? If not nature, then who? But these shapes don't appear overnight. They're ancient, etched slowly by the rhythms of a planet we're only beginning to understand. Some formations even hint at changes over time. There are transitional zones where the polygons seem partially erased or stretched, as if the land itself shifted mid pattern. This suggests an ongoing process, one that may still be active today. If confirmed, it would mean Mars is not the frozen, geologically dead planet we once assumed, but a world where the ground itself moves in silence, breathing in cycles of frost and dust. What's also worth noting is that these polygonal fields have been found near locations where other Martian mysteries emerge, near ice cliffs, within ancient lake beds, and alongside dunes that shift with seasonal winds. Their presence in such diverse landscapes hints at something more than just a quirk of temperature. They may be a signature of Martian climate history, a subtle record of its coldest chapters, written in frozen lines across the soil. And though rovers like Curiosity and Perseverance have rolled past them, they've yet to study them up close in great detail. Most images come from orbit, wide, sweeping views that show the patterns in full. To understand their chemistry, their depth, and whether they mark the presence of subsurface ice or briny layers, future missions would need to dig deeper, quite literally. For now, these ancient tiles of Martian ground remain like whispers of an algorithm we haven't cracked. They're quiet proof that even in silence, the planet is speaking, just not in words, but in patterns. And patterns, especially ones that repeat with such elegance, always leave us wondering what they mean and whether someone or something once knew how to read them. Across the dry plains and dusty basins of Mars, long looping lines cut through the surface like the brushstrokes of an invisible artist. These aren't caused by rivers or machines, they're winding, twisting trails that seem to wander without direction, often stretching for hundreds of meters or more. These are dust devil tracks, silent traces left behind by spinning columns of Martian air. They form when the thin atmosphere of Mars heats unevenly under the sun. Warm air rises quickly from the surface, while cooler air presses down, causing a column of rotating wind to form, much like a miniature tornado. But unlike Earth's tornadoes, these Martian dust devils are often far taller than anything we see on our own planet, stretching up to 10 kilometers high, nearly the height of Mount Everest, while remaining relatively narrow at their base. As these spiraling towers of wind race across the ground, they suck up the top layer of fine reddish dust and expose the darker surface beneath. What's left behind is a dark, winding path, a footprint marking where the dust devil once traveled. The contrast is so sharp that orbital cameras, like those on NASA's Mars Reconnaissance Orbiter, can spot these tracks from space. To the eye, they resemble paint streaks, crisscrossing each other like the tangled flight paths of birds. Some of the tracks curve in gentle arcs, while others make tight loops or zigzag across rocky terrain. Many appear where conditions are warmest, especially near the equator during the Martian spring and summer, and they can vanish over time as fresh dust settles again over the surface. But some linger far longer than expected, even surviving through entire seasons. What adds to the mystery is that many of these tracks appear without any visible dust devil ever being captured. Rovers and orbiters have recorded sudden changes in track patterns without detecting the whirlwinds responsible. It's like waking up to find footprints in the snow, but no sign of who or what left them. This has led some researchers to believe that many dust devils on Mars might be transparent, too weak to lift much material, but still strong enough to disturb the surface. Others may move too quickly or form and disappear in moments, making them hard to observe directly. Rovers like Spirit, Opportunity, and Perseverance have encountered dust devils up close. At times, their cameras have caught the swirling clouds moving silently across the plains. The rovers even register sudden changes in air pressure as these devils pass by. In some cases, the spinning winds have unexpectedly cleaned off the solar panels of older rovers, giving them a second life by removing layers of dust that had built up over months. It's one of the few instances where Mars seems to help rather than hinder our machines. But the tracks themselves still hold secrets. Some move in ways that don't follow expected wind patterns. Others appear to intersect or form grids, as if guided by something other than the randomness of weather. There are rare cases where tracks lead into areas that are colder or shaded, where dust devil activity should be unlikely. And then there are tracks that appear to stop abruptly, as if whatever caused them simply vanished into thin air. In certain regions, such as Amazonas Planitia and Gusev Crater, the density of these tracks is staggering. It's not just one or two here and there, it's hundreds, sometimes thousands, like veins running across the land. They overlap, weave around craters, and sometimes spiral into tight, cyclone like shapes. Studying these areas helps scientists learn not just about Martian weather, but also the consistency of the soil and the movement of particles over time. Even stranger is the fact that similar patterns have never been seen forming in quite the same way on Earth. Our planet has dust devils, but they don't leave long lasting marks like those on Mars. The difference is partly due to gravity, air pressure, and surface material. Mars' dry, fine dust, combined with its thin atmosphere and extreme temperature swings, makes it the perfect canvas for these atmospheric brushes. In satellite imagery, these tracks sometimes resemble ancient trails or the faded remnants of writing, like Mars itself is trying to communicate in swirls and spirals. And because they're so fleeting, appearing and disappearing with the weather, they also remind us how alive this supposedly dead planet really is. Each track may only last a few days or weeks at most, but they are proof that something is still moving up there, dancing across the surface, shaping it, even if just for a moment. And with every new track spotted, the question remains, how many more are forming right now, silently drawing lines across a red world that continues to whisper in dust? On the barren plains of Mars, where every rock is a clue and every shadow is studied, one peculiar formation captured attention, unlike most. A single object, small, curved, and hollowed, was photographed by the Curiosity rover in Gale Crater. Its shape was unlike the jagged shards or wind-smoothed stones that typically dot the Martian landscape. This one looked almost biological, like something once alive. Some called it the shell rock. What made it so strange wasn't just its appearance, it was how it defied easy explanation. The structure was arched, almost like a curled leaf or the outer casing of a sea creature. It had a smooth interior curve and an opening that resembled a shell's mouth, a formation so oddly shaped that even seasoned geologists hesitated before labeling it just another rock. Because on a planet where we're still trying to understand the story of water, the possibility of past life, even primitive life, makes every anomaly feel heavier, more urgent. Initial guesses were cautious. Some proposed it could be the result of ancient volcanic activity, maybe a gas bubble that formed inside lava, cooled, and cracked open. Volcanic bombs, as they're called, can sometimes leave hollow cavities in cooling basalt on Earth. And Mars certainly had volcanic history, but even volcanic bubbles rarely show the clean arch or symmetry that this object displayed. Others lean toward the theory of erosion. Could it be that Martian winds, blowing for millions of years, had carved out the rock naturally? Mars is no stranger to wind sculpted features, but erosion usually leaves surfaces pitted, irregular, and battered. This one seemed delicate, too purposeful in its curve, too precise in its proportions. And more than that, it didn't look like it belonged in its surroundings. Everything around it was rough, broken and angular. This rock stood out like a fossil in fresh cement. That word fossil kept creeping into discussions, not as a claim, but as a possibility. On Earth, shell fossils are among the most common traces of early life, especially for marine organisms. Their structures persist in stone for millions of years, curved, ribbed, and hollow. And while Mars was never an ocean covered world like Earth, we know that liquid water once flowed across its surface. Riverbeds, lake basins, and even signs of standing bodies of water have been found through satellite imagery and surface exploration. If life ever developed in those ancient waters, even in microbial or soft bodied form, could it have left behind remnants like this? Adding fuel to the speculation, the shell rock doesn't seem to have a known match in the catalog of Martian geology. NASA hasn't officially classified it as volcanic or sedimentary. It hasn't been dismissed as debris from the rover itself. It's just there, mysterious, observed, noted, and then passed over. No additional data, no follow up close ups, no chemical analysis released to the public. It's like an unsolved word left floating mid sentence. Online, the image spread fast. Enthusiasts compared it to clamshells, snail casings, and even fossilized coral. Some skeptics argued it was a trick of lighting, that the smooth inner curve was just a shadow cast by a tilted rock. But others zoomed in, adjusted angles, sharpened contrast, and still found that nagging feeling that something was off. The smoothness, the proportion, the hollowed chamber. It didn't just look like a rock shaped by nature. It looked like something that once served a function, or sheltered something. The curiosity around this object also touches a deeper frustration among many who follow Mars missions closely: the silence. NASA and other space agencies are cautious about fueling public speculation. They prefer to avoid words like fossil or artifact unless there's overwhelming peer reviewed evidence, and understandably so. But this cautious approach often leaves some of the most intriguing images unexplained for years, or indefinitely. The shell rock remains in that strange limbo, fascinating enough to raise eyebrows, yet too ambiguous to make headlines. It's not the first anomaly found on Mars that blurs the line between geology and biology, and it likely won't be the last. But what makes this one linger in memory is how it resembles something familiar, something earthly, like a fragment of a seashell left on a beach after the tide has gone out. Only the beach is dusted in red sand, and the sea, if it ever existed, has been gone for billions of years. There's a quiet power in such images. They remind us that Mars still holds secrets, some hiding in plain sight, and they leave us wondering, how much do we miss when we assume everything strange is just a rock shaped by chance? Because on a world that may have once cradled rivers, lakes, and something more, every unusual curve could be a clue to a past we're only beginning to see. It was August 2014 when NASA's Curiosity rover captured yet another image that would soon ripple through the internet like a shockwave. In the dusty sands of Mars, halfway embedded in the surrounding rock, lay an object that didn't look like a rock at all. It was long, narrow, slightly curved, and to many who saw it, unmistakably shaped like a human femur. The image became instantly famous. It was quickly dubbed the Martian thigh bone. To the casual eye, it did look strangely anatomical. It had the shaft of a femur, the rounder end resembling a ball joint, and even a smoothness that felt more biological than geological. For many observers, it sparked a single jarring question: was this evidence of something once alive on Mars? Of course, NASA didn't take long to respond. Their official statement pointed to wind and natural erosion, explaining that Mars has a long history of sandblasting forces that shape rocks in odd ways. According to their scientists, this so called bone was nothing more than a strangely weathered rock. No bone tissue, no organic material, no fossilization, just mineral. But even with that explanation, something about the image refused to settle quietly. The shape was just too specific, and the timing, well, that only added fuel to the fire. At the time, the world was becoming increasingly interested in the search for life beyond Earth. Mars, with its hints of ancient water and atmospheric mysteries, was the prime suspect. So when something that looked like a piece of a skeleton showed up, people didn't just brush it off. They zoomed in, enhanced the contrast, rotated the image, and debated its origin across forums, blogs, and social media. Some saw the thigh bone as a classic case of pareidolia, the brain's tendency to recognize familiar patterns in random shapes, like seeing faces in clouds or animals in tree bark. Others weren't so quick to dismiss it. They asked why so many of Mars's strangest formations, from the skull rock to the spoon, and now this bone, kept resembling things from Earth. Could so many familiar shapes really be coincidence? Geologists explained that in dry, windy environments like Mars, rocks can be eroded into tube-like or elongated forms. They showed Earth-based examples from deserts in Arizona or dry valleys in Antarctica, rocks that had been sand-polished into eerie, organic-looking objects. But even those comparisons didn't always match the cleanness of the Martian bone. On Earth, such shapes often still show signs of chipping or rough edges. The object on Mars had an almost unnatural symmetry, too smooth, too consistent. Adding to the mystery was the lack of further analysis. NASA didn't send Curiosity back to that exact spot for a closer look. No follow-up chemical scan, no second angle, no detailed imaging. It was one frame in a series, captured during a routine sweep, and then nothing. The rover moved on, which is common practice. But for those watching from Earth, it felt like the biggest questions were being left unanswered. Speculation poured in. Some imagined the thigh bone belonged to a long-dead Martian species, not necessarily human, but perhaps something primitive, reptilian, or entirely alien. Others suggested it might be a relic from a spacecraft crash, a mechanical rod broken off from an ancient, unknown probe. A few went further still, theorizing cover-ups and withheld data, pointing to the pattern. Many of Mars's most debated anomalies are photographed, acknowledged, and then quietly forgotten. What makes the thigh bone photo particularly haunting isn't just the shape, it's the context. It was found in a region that had once shown signs of water flow, where smooth sediments and rounded pebbles hinted at ancient streams. If life did ever exist on Mars, these wetter regions would have been the likeliest place to find it. That simple fact gave the bone more weight in the public imagination. Even if it was just a rock, the idea of what it resembled and where it was found stirred something deeper than a scientific explanation could settle. The debate continues. Years later, people still reference the image in discussions about alien life. It's shown in documentaries, conspiracy videos, and academic panels alike, always with that same question hovering in the background. What if? What if the photo really did capture something more than mineral? Because when the surface of another planet begins to reflect images we know from home, bones, books, skulls, wires, it becomes harder to ignore the echoes of possibility. The Martian thigh bone is still sitting in NASA's image archive, cataloged as just another rock. But to many who've seen it, it's not just another rock. It's a silent, stubborn mystery, one that reminds us how much we don't know, and how quickly the line between imagination and discovery can blur in the red dust of a distant world. As Curiosity and its fellow rovers made their way across the rugged Martian terrain, most of the mission's hiccups could be traced back to ordinary causes: dust storms, extreme temperatures, power draw fluctuations. But not all disruptions were so easy to explain. Over time, engineers and space enthusiasts alike began to notice an odd pattern. Some of the most curious and controversial photos captured by the rovers, images that sparked debate, speculation, even viral headlines, were oddly close in time and location to moments when the rovers experienced sudden, unexplained malfunctions. These weren't just routine resets or the kind of errors that come with years of exposure to radiation. In certain places, particularly around regions where strange objects or shapes had been photographed, like the spoon rock, the so called thigh bone, and strange geometric ridges, systems would glitch in unusual ways. Instruments would stop responding, cameras would freeze mid capture, communications would become patchy, even though the weather was clear and the solar panels were fully powered. Sometimes, data that had been scheduled for upload would go missing or become corrupted, requiring retries that never quite completed. It's important to note that Mars is an extremely harsh environment. The temperature swings alone are enough to stress delicate electronics, and the planet's thin atmosphere does little to shield machines from cosmic rays or solar radiation. But even with all these factors in mind, the timing of some glitches didn't sit right. In a few cases, the rovers were operating smoothly until they entered areas where previous anomalies had been observed. Then suddenly, things went wrong. One of the most cited examples occurred near a region where an oddly rectangular rock formation had been photographed by Curiosity. The image stirred speculation due to its unnaturally straight edges and perfect 90-degree angles, but just after those photos were taken, several onboard systems began to misbehave. The navigation computer logged strange gyroscopic data that caused the rover to pause and enter safe mode. Engineers back on Earth managed to recover it, but they were puzzled by the root cause. It wasn't heat, it wasn't terrain. Nothing in the diagnostics matched previous failure patterns. In another instance, Perseverance, the newest rover to join Mars's exploration team, was traversing an area of layered bedrock thought to be a dried ancient river delta, one of the best spots to search for signs of past microbial life. Just as it began using its ground penetrating radar to image below the surface, the system temporarily froze. Not only that, but its microphone, which had been recording sounds of Martian winds, crackled and went silent. Once again, the event was brief, and eventually things returned to normal. But the logs revealed one thing: the interruption happened at the exact time the rover rolled past an oddly symmetrical mound that had caught the attention of researchers in earlier orbital imagery. In mission summaries, these events are often downplayed or listed as expected anomalies given the environment, and that may be true. Yet the fact that these interruptions cluster around areas rich in visual or geological mystery continues to draw attention. Some speculate that electromagnetic interference caused by subsurface materials could be to blame. Others wonder if buried metal or even radioactive deposits might interfere with rover instruments, just like certain spots on Earth disrupt compasses or radio equipment. But not everyone is satisfied with these technical theories. Some believe that the zones where these glitches occur may hold secrets we're not yet equipped to understand, that the interruptions aren't random, but rather a kind of passive resistance, regions on Mars that don't just appear unusual, but react in strange ways when approached. This line of thinking, while speculative, taps into a deep unease. What if we're stumbling upon something that doesn't want to be found? Interestingly, internal NASA logs have redacted or restricted some of the diagnostic data from these episodes. That in itself isn't necessarily suspicious. Government agencies frequently limit public access to raw data until it's been fully processed and reviewed. But when paired with the fact that public rover updates tend to skip over the most problematic timelines, it raises questions. Why aren't these incidents investigated more thoroughly in public reports? Why do so many of them line up with places where the most eyebrow raising images come from? As more rovers prepare to make their way across the Martian surface, and as future missions plan to retrieve samples or even send humans, the hope is that more answers will follow. For now, though, these scattered malfunctions remain part of the planet's silent conversation with us, a planet that is seemingly still, yet somehow responds in ways we can't always predict. And in those moments when the machines go quiet or behave strangely, some can't help but wonder if Mars is listening too, or worse, watching. Near the horizon of certain Martian landscapes, strange shapes rise like silent sentinels, structures so tall and slender that they defy easy explanation, captured by orbiting satellites like Mars Reconnaissance Orbiter, and in some cases, hinted at in rover camera feeds. These so called tower like formations appear as thin vertical spires projecting from the planet's dusty plains and rocky escarpments. What's most striking is their geometry, how unnaturally narrow and upright some of them seem compared to the rounded and broken down shapes we typically associate with erosion. In one widely circulated image, a long shadow stretches across the red ground, cast by what looks like a solitary vertical structure. The object appears needle thin, yet surprisingly tall, its dimensions inconsistent with most geological formations caused by wind, water, or even volcanic activity. The angle of the shadow suggests it rises dramatically from the surface, and though the exact height is difficult to measure from the photos alone, estimates based on the length of the shadow put it at several meters tall, far taller than the width of its base would suggest is stable for natural rock. That, in itself, is peculiar. On Earth, when erosion leaves tall standing features behind, like desert hoodoos or sea stacks, they usually have wide bases or are part of a cluster supported by layers of harder rock that resist the elements. But these Martian towers seem to defy that rule. Some appear in isolation, surrounded by flat plains or gently rolling hills with no clear source for their vertical birth. Others emerge near crater rims or amid rocky outcrops, yet still manage to stand apart, thinner and more angular than anything around them. One theory is that these are volcanic necks, the hardened cores of ancient volcanoes whose softer outer layers have eroded away over millions of years. That happens on Earth too, in places like Shiprock in New Mexico. But for a volcanic neck to remain standing without collapsing under Mars's thin atmosphere and frequent dust storms, it would have to be made of exceptionally durable material. And the frequency of these tall spires, along with their visual uniformity in certain regions, makes some scientists question whether this explanation fits all cases. Others propose that these towers could be mineral veins left behind when water once flowed through cracks in the rock, then evaporated, leaving harder materials behind. Over time, erosion might remove the softer surrounding rock, exposing the mineral column. But again, this would usually result in structures that are irregular, branching, or stubby, not uniformly vertical needles projecting skyward like ancient antennas. What adds to the mystery is how little official attention these spires have received in public reports. While NASA has acknowledged the existence of some of these features, the level of detail in available documentation is minimal. No major press releases, no detailed geological breakdowns, and very few follow up images. It's not uncommon for odd features on Mars to be passed over if they fall outside a mission's core objectives, but given how strange and eye catching these towers are, the silence feels more pronounced, and this lack of detailed study has created fertile ground for speculation. Some believe these spires might be remnants of artificial structures, ruins left behind by an ancient Martian civilization, or the decayed remains of unknown technology. The idea may sound far-fetched, but the visual effect of the images is hard to shake. There's something undeniably eerie about a tall, narrow spike rising from otherwise desolate terrain, especially when its origin is unexplained and its shape so out of place. Skeptics argue that these are simply illusions, artifacts of light, shadow, or camera angle. From orbit perspective can easily distort size and shape, especially when viewed at low sun angles that stretch shadows dramatically. Some towers may in fact be short, stubby rocks exaggerated by the way the light hits them. But not all of them can be explained this way, especially when multiple satellite passes capture the same features from different angles and the results remain consistent. Interestingly, some of the most striking tower-like shapes have been spotted in regions where other anomalies have appeared, places where patterns, odd formations, or past rover malfunctions have occurred. This overlap isn't necessarily meaningful, but for those paying close attention to Mars's many mysteries, it adds another thread to an already tangled web. Why do so many strange and unexplained features seem to cluster in certain zones? Whether these towers are geological quirks, illusions, or something we have yet to fully understand, they continue to fascinate scientists and the public alike. With future missions aiming to land in more geologically diverse areas, and with orbiters constantly capturing new high resolution images, it's likely that more of these spires will be documented. But until then, they remain some of the planet's most quietly haunting features. Thin, towering shapes standing watch in the silence of a desert world, their shadows stretching across a landscape that still refuses to give up all its secrets. At some point in Mars's distant past, something changed drastically. Today, the red planet is cold, dry, and silent, its skies thin, and its surface exposed to radiation. But that wasn't always the case. Clues buried in its rock layers, craters, and canyons suggest Mars once had a much thicker atmosphere and flowing water across its surface, perhaps even a vast ocean covering much of its northern hemisphere. If that's true, the obvious question follows: what happened to it all? To understand the mystery of Mars's lost atmosphere, scientists have turned to both surface data and satellite observations. The ancient riverbeds, deltas, and lake basins observed from orbit point to a world that once had enough atmospheric pressure to allow liquid water to flow. Today's Martian air is far too thin for that, barely 1% the thickness of Earth's atmosphere. Water on modern Mars doesn't just evaporate, it sublimates, turning directly from ice into vapor. That means at some point, Mars lost nearly all of its air. But how does a planet lose an atmosphere? One major suspect is the Sun. Billions of years ago, when Mars was still young, the Sun was more active and volatile, sending out bursts of solar wind, streams of charged particles that slammed into planetary atmospheres. Earth is protected by its strong magnetic field, which deflects most of this radiation. Mars, however, lost its global magnetic field early in its history. Without that shield, the solar wind had direct access to the upper layers of its atmosphere, slowly stripping it away. NASA's MAVEN mission, short for Mars Atmosphere and Volatile Evolution, was sent specifically to investigate this process. The spacecraft revealed that Mars is still losing atmosphere today, just at a much slower rate. It found evidence that particles in the upper atmosphere are continually being swept into space by solar radiation. Extrapolate that process over billions of years, and you begin to see how a once thick atmosphere could gradually vanish, leaving the planet dry and exposed. But the atmosphere wasn't the only thing to disappear. If Mars once had rivers and lakes, those must have come from somewhere, and the most dramatic theory is that it had a northern ocean. Mars is not perfectly symmetrical. Its southern hemisphere is filled with highlands and craters, but the northern half is far smoother and lower in elevation. In fact, that basin is so vast and flat that some scientists believe it may have been the bed of an ancient ocean, possibly covering as much as a third of the planet's surface. Supporting this theory are signs of ancient shorelines, sediment deposits, and mineral patterns that suggest water once pooled and lapped along coastlines. Some of the planet's massive canyons, like those near the Crise Planitia region, might have been carved by catastrophic floods, perhaps when underground water reservoirs suddenly burst out and raced toward the lower plains. Still, others point to climate cycles. It's possible Mars went through periods of relative warmth and humidity, followed by freezing dry spells. During the warmer periods, ice would melt, rain could fall, and water would flow. Then, as the planet cooled or the atmosphere thinned, everything froze again. Some of the water may still be there, locked beneath the surface in frozen aquifers or trapped in polar ice caps, waiting to be discovered. But despite all these theories, there's still no clear answer to where the ocean ultimately went. If it simply evaporated and escaped into space, it would have required an incredibly long time and a tremendous loss of atmosphere to do so. If it froze underground, then there might still be vast ice reserves hidden below the dusty crust. And if parts of it seeped deeper, could there still be liquid water moving in underground channels even today? This uncertainty drives much of the curiosity surrounding Mars. Every new satellite image, rover drill, or spectrometer reading is another chance to piece together what happened. Missions like Perseverance aren't just looking for signs of past life. They're also hunting for chemical traces left by ancient water, salty deposits, clay minerals, and patterns in rock layers that might whisper stories from a time when the air was thicker and the planet breathed. The idea of a once blue Mars stirs the imagination. Picture waves crashing on Martian shores, clouds drifting across a thicker sky, and a planet with a climate not so different from early Earth. It's the kind of vision that makes you wonder, not just about what was lost, but why. What forces reshaped an entire planet? Was it simply bad luck in the cosmic lottery, or is this what happens when a world can't protect itself? And the implications reach beyond Mars. If an entire atmosphere and global ocean can vanish from one planet, what does that say about the fragility of conditions elsewhere? Could Earth, given the wrong circumstances, suffer a similar fate? As we peer into the silence of Mars's past, we're also looking into a mirror, a reflection of our own planet's delicate balance. And so we keep searching, digging into dust and drilling into rock, chasing answers buried in red soil and lost skies. Because whatever happened to Mars's atmosphere and oceans, it left behind a haunting question that lingers with every new discovery. Could it happen again somewhere else, or even here? Everything we've explored, from ancient riverbeds and vanishing oceans to eerie skull-shaped rocks and mysterious towers, wasn't pulled from the pages of science fiction. It all came from real missions, real data, real photographs. Every crater, every odd shadow, every rock formation that looked just a little too perfect, all of it captured by NASA's own orbiters, landers, and rovers. Machines like Viking, Curiosity, Perseverance, and Insight have spent decades exploring the red planet, slowly pulling back the dusty curtain on a world that still refuses to give up all its secrets. We didn't invent the face on Mars. It was first photographed by Viking 1 in 1976. We didn't sketch the polygon patterns in the ground or the monolith on Phobos. They're all part of the public record, sitting quietly in image databases, available for anyone to see. We didn't imagine the odd fiber-like formations, the shell-shaped rocks, or the tower-like spires casting long shadows across the surface. They were sent back to Earth, pixel by pixel, by robots millions of miles away. What we did do was look at them and wonder. But maybe wonder is the beginning of something bigger. Because when you strip away the conspiracy theories and the internet debates, what you're left with is a planet that behaves just strangely enough to keep us guessing. A planet that looks dead but speaks in whispers. A planet that once had water, wind, perhaps even warmth, and now wears the scars of some forgotten transformation. There's no narrator in space. Mars doesn't explain itself, it just waits, silent, patient, covered in the dust of time. And maybe that's why we're drawn to it, not because it shouts answers at us, but because it invites us to keep asking better questions. Take a moment and think about how much we've seen, yet how little we truly understand. From the Cydonia region, with its almost human looking face and nearby pyramid like ridges, to Inca City's grid of mysterious lines near the South Pole, to rock formations that eerily resemble books, bones, and machinery. Some images get brushed aside as illusions, tricks of light and shadow. Others are dismissed as coincidences of erosion or geology. And perhaps they are. But then again, perhaps not all of them. Aldrin once famously said about the Phobos monolith, "We should go there. We should find out who put that there." It's a bold statement from a man who walked on the moon, and it captures the heart of what keeps driving us back to Mars. Not just the desire to explore, but the need to know. Maybe we're not looking for aliens. Maybe we're not hoping to find statues or cities or spaceships buried beneath the sand. Maybe we're searching for something deeper, a missing chapter in the story of life, a clue that tells us how planets rise and fall, a mirror that reflects what might have been and what could still be under the right conditions. Mars is not hiding from us. Every year, more images are released, more scans are made public, more tools are sent across space to examine the surface grain by grain. But we still don't have all the right questions. We still don't know what to make of every odd shadow, every out of place shape, every anomaly that refuses to fit neatly into a box. And that's okay. Science doesn't need to have all the answers right away. What matters is the journey, the act of looking closely, asking honestly, and remaining open to what we find. And if Mars has taught us anything, it's this. Real mysteries don't need to be loud or dramatic. Sometimes they just sit quietly in the sand, waiting. So as we bring this journey to a close, we invite you to sit with the mystery a little longer. Ask your own questions, zoom in on the images, follow the rover tracks, read between the pixels, because this isn't just about Mars, it's about us, our curiosity, our imagination, and our need to make sense of a universe that doesn't always explain itself. And maybe, just maybe, the strangest thing about Mars isn't what we've found, it's what we still haven't. Maybe Mars isn't trying to hide anything. Maybe we just haven't been asking the right questions. Now we want to hear from you. Where are you watching from tonight? Are you curled up in bed, on a late night walk, or drifting off with headphones in? Let us know in the comments below. We'd love to see how far this curiosity reaches across the planet. If you enjoyed this deep dive into Mars' most mysterious discoveries, be sure to give this video a like. It tells the algorithm that you're just as fascinated by cosmic riddles as we are. Subscribe for more nighttime science journeys that blend fact with wonder. Hit the bell so you don't miss what's next. And if you know someone who still thinks Mars is just a dead rock in space, share this with them. They might just see it differently after this. Until next time, stay curious, stay wondering, and keep asking the questions no one else is asking, because sometimes the silence says more than we think.